Across the quiet gulf between stars, there exists a single crimson ember glowing in the darkness. Our nearest stellar neighbor, Proxima Centauri, a star so small it could fit inside our sun 100 times over, yet so close that its faint light touches the edges of our cosmic imagination. Tonight, we drift toward this distant red glimmer, letting its warmth guide us through mystery, wonder, and the hidden architecture of the universe. What secrets wait around the smallest star in our celestial neighborhood? What worlds orbit in its dim embrace? And what might they reveal about our own fragile home? Like and subscribe if you enjoy these journeys. It helps the channel drift farther into the stars. Let's begin. Proxima Centauri sits only 4.24 light-years away, closer than any other star in the entire Milky Way. Yet despite its nearness, it remains invisible to the naked eye, hiding in the southern sky like a quiet cosmic neighbor whispering through the dark. When we speak about distances in space, even a single light-year can feel impossibly vast. It's the distance that light, the fastest thing in the universe, travels in 1 year. A beam of light leaving Proxima today won't reach us until more than 4 years have passed. And yet, on the grand scale of the galaxy, that gap is astonishingly small. If the Milky Way were a continent, Proxima would be the house at the end of our street, a nearby porch light shining faintly through the trees. It is the closest stepping stone in the endless ocean beyond our sun. Still, closeness in astronomy doesn't always translate into visibility. Even though Proxima is right next door, we cannot see it without a telescope. It's too small, too faint, too gentle in its glow. It sits quietly in the constellation Centaurus, far to the south, visible only from certain parts of Earth, and even then, only through the patient eye of magnification. From our view, it's not a bright beacon but a whisper of starlight, hiding among more luminous companions. In truth, the nearest star to Earth is an ember barely bright enough to pierce the cosmic night. Yet its nearness alone has made it one of the most studied and beloved stars in astronomy. Proxima offers something nothing else can, a place where our curiosity feels almost within reach, a star close enough that, for the first time in human history, we can imagine sending a spacecraft there, not in the distant future, but in our own. The Breakthrough Starshot initiative, for example, aims to fire tiny light sail probes toward Proxima using powerful lasers, pushing them to a significant fraction of the speed of light. The idea is almost poetic. Fragile machines, thinner than paper, surfing beams of light across interstellar space. If they succeed, humanity will have touched the outskirts of another star system for the first time. And it all begins with Proxima, the nearest waypoint on the map of the galaxy. Proxima's closeness also makes it a natural laboratory for every question we've dared to ask about life in the universe. If life can exist on planets around this tiny red dwarf, it means life could thrive in countless places across the galaxy. Red dwarfs are the most common stars in the Milky Way, outnumbering stars like the Sun by a huge margin. Knowing what happens around Proxima helps us understand the cosmic average, the baseline from which billions of other worlds might emerge. Every telescope pointed at this quiet ember enriches our understanding of the cosmos. Every passing photon's data teaches us something new about the nature of distant worlds. And every discovery around Proxima reminds us that the universe is not empty. It is alive with possibilities, even right next door. Proxima Centauri may be faint, small, and hidden from our eyes, but in its quiet way, it has become the most important star beyond our sun, a cosmic neighbor, a guidepost, the first door we might one day open as we step beyond our solar shores. If our sun were the size of a giant sphere, Proxima would be a tiny glowing ember beside it. Only a fraction of the sun's mass, it burns slowly and gently, a candle flickering in the cosmic wind. In the vast family of stars scattered across the Milky Way, Proxima Centauri sits among the smallest, a red dwarf of remarkable restraint. Where the sun roars with energy, Proxima simply hums, radiating a soft, steady warmth that barely reaches beyond its immediate surroundings. It contains only about 12% of the Sun's mass, and its diameter is so small that over 60 Proximas could fit across the surface of our star. And yet, this gentle miniature shines with a resilience that challenges everything we think we know about longevity and power in the cosmos. The physics of Proxima's tiny size shape almost every aspect of its identity. Because it has so little mass pressing down on its core, Proxima burns its hydrogen fuel at an incredibly slow pace. Its fusion process is calm, controlled, deliberate, nothing like the Sun's constant turbulent storm of heat and light. The result is a star whose brightness is so faint that, from any Earth-like world nearby, daylight would resemble a deep red dusk. But this quiet burn is also Proxima's great advantage. Small stars like this are not short-lived flames that flare brilliantly and fade away. They are cosmic marathoners. While our Sun will shine for roughly 10 billion years, Proxima Centauri may persist for trillions. It will still be glowing long after the Milky Way has changed beyond recognition, long after the Sun becomes a red giant, long after Earth has turned to dust. In the cosmic calendar, Proxima is not a fleeting moment. It is nearly eternal. This longevity is what makes red dwarfs like Proxima so fascinating to scientists searching for life. A star that remains stable for trillions of years gives planets enormous stretches of time in which life might emerge, evolve, and adapt. Even if conditions fluctuate, the sheer timescale offers endless opportunities. If the Sun is a golden hour, Proxima is an age, an entire epoch of possibility. Yet despite its softness, Proxima's faint glow has a fierce side hidden just beneath the surface. Small stars generate powerful magnetic fields, which can twist, snap, and unleash bursts of energy far more intense than their size suggests. Proxima's flares can briefly shine brighter than the star's normal output, sending ripples across nearby space. This paradox, a calm, slow-burning star with sudden moments of fiery temperament, makes Proxima one of the most intriguing members of our cosmic neighborhood. Even so, its tiny stature continues to challenge our expectations. Stars are often imagined as massive, blazing furnaces lighting up vast regions of space. But Proxima Centauri reminds us that the universe is filled with quiet stars, subtle stars, stars that glow not with brilliance, but with persistence. Its smallness is not a weakness, it is a different kind of power. A reminder that even the humblest objects in the cosmos can shape the fate of worlds. Proxima is small, yes, but in its tiny ember-like glow lies a story spanning trillions of years, outlasting galaxies, civilizations, and even the idea of time as we know it. Red dwarfs burn so slowly that they outlive every star we know. Proxima may shine for trillions of years, long after our Sun becomes a memory drifting through dust. In the grand architecture of the cosmos, longevity is not measured by brilliance, but by restraint. Red dwarfs like Proxima Centauri embody this truth more than any other type of star. They are the quiet sages of the galaxy, small, unassuming, and almost impossibly patient. While stars like our Sun blaze fiercely and exhaust their fuel within a cosmic heartbeat, red dwarfs sip their hydrogen with careful, measured slowness. Their nuclear fusion is calm, efficient, and profoundly deliberate. Because of this, they become the longest-lived objects known, outlasting every galaxy-scale transformation the universe will ever witness. Imagine time stretching out over trillions of years, far beyond the lifespan of the brightest stars we see today. Long after the Sun swells into a red giant and its light fades from the Milky Way, red dwarfs will still be burning. Not loudly, not dramatically, but steadily, like embers that refuse to go out. Proxima Centauri is one such ember. Its slow hydrogen fusion ensures that it wastes nothing, using its energy so gently that it will continue shining long after humanity, Earth, and even the memory of our solar system has disappeared into cosmic history. This extraordinary lifespan makes red dwarfs the true survivors of the universe. They will be the last stars shining when everything else grows cold and dark. In the far future, when the Milky Way has merged with other galaxies, when new stars have stopped forming, when even black holes have begun to evaporate, the faint glow of red dwarfs like Proxima will still flicker. They are the final chapters in the story of starlight. For scientists searching for life, this stability is more than poetic, it's profoundly important. A star that shines for trillions of years offers its planets an unimaginable gift. Time. Time to cool. Time to settle. Time for chemistry to grow complex. Time for life to emerge, adapt, and flourish in ways we can't yet imagine. Around stars like Proxima, evolution could unfold not just over billions of years, as it did on Earth, but over epochs so vast they defy comprehension. And yet, Proxima's long life comes with challenges. Its small size gives it a powerful magnetic field, capable of triggering violent flares that could strip atmospheres and fry the surfaces of close-orbiting planets. This paradox, eternal life paired with sudden bursts of intensity, is part of what makes red dwarfs so fascinating to astronomers. They are both gentle and fierce, serene and unpredictable. Still, even with its tempests, Proxima remains a symbol of cosmic endurance. It is a star that will watch the galaxy change and age around it, a relic of the universe's earliest days and a witness to its distant future. When all other stars have dimmed, red dwarfs will remain, glowing softly across the dark. Proxima Centauri is not just a star with a long life. It is a star with almost eternal life, a beacon that will endure long after time has reshaped everything else. Proxima's red glow is not bright but soft, spilling into space like the calm breath of a sleeping giant. Its light takes more than 4 years to reach us, carrying messages from a time before we even asked the questions. Light is the universe's oldest storyteller, and Proxima Centauri speaks in a language of quiet crimson. Unlike the sun's brilliant white shine, Proxima emits a warm, deep red glow, the kind of light that feels less like illumination and more like a gentle exhale. It doesn't blaze across the void. It drifts, it glows, it whispers. If stars had personalities, Proxima would be the philosopher, contemplative, patient, unhurried. Its photons leave the star with humble momentum, beginning a journey that will last years before reaching the waiting eyes of Earth. This distance, just over 4 light-years, becomes almost poetic when you think about what light truly is. Every photon that arrives at our telescopes tonight began its journey before many of our own thoughts, dreams, or decisions existed. The light we see from Proxima is not the star as it is right now, but as it was years ago. Starlight is time travel made visible. When you look at Proxima, you're looking into the past, peering across a gulf where time stretches and slows, offering us a glimpse of what once was. Because Proxima is so faint, its glow barely reaches us. Even the most pristine night skies can't reveal it to the naked eye. Only through magnification, carefully pointed telescopes or sensitive detectors can we gather enough of its soft light to perceive it at all. This faintness is one of the many reasons Proxima feels like a hidden treasure, a star known not through sight but through listening. Listening to the delicate fingerprints its photons leave behind. Those tiny packets of light carry clues about the star's temperature, its chemical makeup, its magnetic storms, and even the planets orbiting around it. By dissecting Proxima's fragile glow, astronomers can detect the slight wobble of the star tugged by Proxima b, or the subtle dimming caused by flares and storms rippling across its surface. Each beam of light is a data capsule crossing interstellar space, a messenger delivering news from the nearest star system. And despite its whisper-soft glow, Proxima's light defines the experience of its planets. On Proxima b, daylight would feel like the warm red hue of a never-ending sunset. Shadows would stretch softly, colours would shift into deeper tones, and the world would live beneath a constant muted glow. To stand on that distant planet and look up would be to see a sky painted in shades of ember and twilight, a sky where the star never quite blazes but hums gently with warmth. This subtle illumination may create conditions unlike any Earth-like world we've imagined. Plants, if they exist there, could evolve to absorb deeper wavelengths. Oceans, if present, might shimmer dark ruby. Proxima's light doesn't dominate. It shapes, molds, influences slowly and quietly over billions of years. Light that moves like a whisper is still light. It still tells stories. And in Proxima's gentle glow, we find a reminder that even the smallest stars, even the faintest celestial embers, have the power to illuminate entire worlds and ignite our endless curiosity. Orbiting within the star's habitable zone, Proxima b has become a symbol of hope. Earth-sized, temperate, and close enough to feel familiar, yet exotic enough to rewrite what we imagine life can be. Proxima b earned the world's attention the moment it was discovered. It wasn't just another distant exoplanet among thousands. It was the nearest potentially habitable planet outside our solar system, a world orbiting the star just next door. For the first time in human history, we weren't staring across hundreds of light years to find a rocky world where liquid water might exist. We were looking at a planet practically on our cosmic doorstep. In astronomical terms, this is the equivalent of discovering an island just beyond the horizon of our home shore, after centuries of believing the ocean went on forever. Proxima b orbits incredibly close to its star, far closer than Mercury does to the Sun. But because Proxima Centauri is such a small, cool red dwarf, that intimate distance places the planet in its habitable zone, where temperatures could allow liquid water to pool, flow, or freeze into delicate patterns across its surface. This delicate, narrow region is where life as we know it has the best chance of taking hold, and Proxima b sits right in the heart of it. Yet despite this familiar-sounding promise, Proxima b is no Earth twin. If anything, it is a mirror held at a strange angle, showing us possibilities rather than reflections. The planet likely has a year only 11 days long. Its orbit is so tight that it may be tidally locked to its star, meaning one side always faces eternal daylight, while the other remains in endless, frozen night. Imagine standing in the Terminator zone, where day meets darkness, and watching a permanent golden-red horizon glowing in a sky that never changes. No sunrise, no sunset, just everlasting twilight. The conditions on Proxima b depend heavily on whether it kept an atmosphere. This is the central mystery astronomers are working to unravel. Proxima's frequent stellar flares might strip a thin atmosphere away, leaving a barren, rocky world exposed to harsh radiation. But if Proxima b formed with a thick atmosphere, or a magnetic field strong enough to protect it, then its surface could be far more hospitable. Winds would shuttle warmth around the planet, smoothing temperature extremes and softening the divide between light and darkness. If Proxima b does have an atmosphere, it may be rich in strange chemistry. Plants, or photosynthetic life, if they evolved there, would not be green like ours. They might be black, deep purple, or dark crimson, adapted to capture the red-hued light of a dwarf star. Oceans might gleam dark and metallic. Clouds might swirl in muted tones. The planet could be a world of soft shadows and deep colors, sculpted by the touch of a star far gentler than the sun. What makes Proxima b truly captivating is not just the science, but the symbolism. It represents the first destination humanity can realistically dream of reaching outside our solar system. Future starships, robotic probes, and interstellar sails will almost certainly aim for Proxima b. It is the closest canvas on which nature may have painted something astonishing or quietly barren. Either way, the mystery fuels our imagination. Proxima b is more than a hidden planet. It is a quiet invitation, a reminder that the universe is far from empty and that the closest wonders may still be waiting just beyond our current reach. Proxima b may be tidally locked, with one side forever facing its star. Eternal sunrise washes one hemisphere in perpetual warmth, while the other lies in unbroken shadow. On Earth, we take rotation for granted. Sunrise, sunset, the rhythm of morning and night. These cycles shape everything from weather to biology. But on a tidally locked world like Proxima b, that comforting rhythm never comes. Instead, the planet may turn only once per orbit, keeping one face stretched endlessly toward Proxima Centauri, while the opposite side remains frozen beneath a sky where the star never rises. The world becomes split in two, a hemisphere of unending day and a hemisphere of eternal night. Imagine standing on the day side. Above you, Proxima would hang in the sky like a giant red ember, unmoving and unwavering. It would never arc across the heavens or set below the horizon. It would simply linger in one fixed place, illuminating the world with a dim, warm glow, a perpetual sunset cast in deep, crimson hues. Shadows would stretch infinitely, never shifting, never softening. Colours would appear muted, as if the world were painted in shades of rust and ember. Temperatures on this day side could be warm enough for liquid water to exist, depending on the atmosphere's thickness. Heat from the star would pour down onto the same region constantly, creating deserts of scorched rock or steaming oceans simmering under the red glow. If clouds formed, they might gather permanently around the substellar point, the one place directly beneath the star, creating a bright, glowing eye in the sky where storms swirl but never drift away. Now step across the horizon into the eternal night. Here, Proxima b becomes alien in a completely different way. Darkness dominates everything. The stars would shine with crystalline clarity, unmoving in a black sky that never brightens. Temperatures could plummet dramatically, cold enough for the atmosphere to freeze and fall as strange, icy snow. Mountains might be carved by frozen winds, oceans locked beneath layers of ice stretching for hundreds of kilometers. But darkness does not mean lifelessness. If the planet has a thick enough atmosphere, winds could redistribute heat from the day side to the night side, preventing the air from collapsing and smoothing the extremes. In that case, the night hemisphere might be cold but stable, a deep, dark landscape illuminated only by distant starlight and the shimmering glow of auroras triggered by Proxima's flares. Yet the most fascinating place of all lies between these two extremes, the terminator line, a thin ribbon of perpetual twilight circling the planet like a glowing boundary between worlds. Here, temperatures might be mild. Day and night meet in balance. The star hovers permanently at the horizon, casting the landscape in soft, dim gold. Rivers could flow. Clouds could drift. Life, if it exists, might cling to this eternal dusk, adapted to the dim red glow and gentle stability of a sky that never changes. To live in such a world is to abandon the very concept of time as we know it. There are no days, no nights, no seasons, only the slow pulse of a star that never moves and a planet that never turns. Proxima b, if tidally locked, is not just a planet, it is two worlds bound together, one of fire, one of ice, wrapped in a twilight ring where possibility may bloom. A world sculpted not by rotation, but by stillness. On Proxima b, the sky might shine in deep crimson hues, a world bathed in permanent red twilight, where the star never rises high. From the moment you step onto the surface of Proxima b, if indeed a surface awaits, the first thing you would notice is the quality of the light. It would be unlike anything on Earth. Instead of the familiar blue dome overhead, the sky may glow in rich, velvety reds, purples, and muted oranges. This is because Proxima Centauri, a red dwarf, emits most of its light at long, reddish wavelengths. To human eyes adapted to Earth's brighter sunshine, the world would appear dusky, subdued, as if lit by a never-ending sunset. Proxima b orbits so close to its star that the star never climbs high in the sky. It hangs low on the horizon, fixed, unwavering, like a crimson lantern suspended in a permanent twilight. The light it casts is dim, soft, and strangely intimate. Even at what passes for noon, the world would feel like an early evening on Earth, the kind of quiet hour when shadows lengthen and the sky deepens into rich colour. If Proxima b has an atmosphere, its skies could take on shades even more exotic. Molecules scatter red light differently than blue, especially under dim illumination. Instead of Rayleigh scattering, brightening the sky into a brilliant azure, Proxima b's skies might darken into maroon or wine-colored tones. At the edges of the horizon, faint rings of orange could blend into shimmering purples, creating gradients of color never seen on Earth. Every moment would feel like dusk, gently breathing across the land. Clouds on Proxima b, too, would appear surreal. In red light, water vapor clouds might reflect darker, rust-colored hues. If the atmosphere contains volcanic dust, exotic chemicals, or ice crystals, the clouds could gleam with metallic sheens, silvers, violets, or even black silhouettes against the dim backdrop. Imagine storms rolling across this world, not bright white thunderheads, but deep crimson towers illuminated by flashes of faint lightning filtered through a scarlet haze. At night, if the planet has a true night side, or if you stand far from the substellar point, the stars would blaze with piercing clarity. With Proxima's dim glow absent or distant, the Milky Way might stretch overhead like a river of diamonds across ink. But even the night sky may not be entirely dark. Auroras, ignited by Proxima Centauri's frequent flares, could shimmer brilliantly across the horizon. These auroras might take on deep red, violet, or even infrared hues, invisible to human eyes but radiant in their own way. They would ripple and pulse like curtains of luminous smoke, dancing silently over the landscape. If life evolved under these skies, it would almost certainly look different from anything on Earth. Photosynthetic organisms might be adapted to absorb red and infrared light, giving them dark, nearly black pigments. Fields of alien vegetation could stretch toward the dim star, absorbing every photon they can catch. The entire world might glow with a quiet, subdued palette, muted colors shaped by a star that gives just enough light to survive, but not enough to overwhelm. The glow of alien skies on Proxima b is more than just a visual curiosity. It's a window into how worlds adapt to their stars, how light shapes landscapes, climates, and life. A world bathed in red twilight challenges our Earth-centered expectations, reminding us that beauty exists even in dimness. Under the crimson skies of Proxima b, the universe feels close, intimate, a quiet glow whispering across an alien world. Proxima b has a pull that grips everything firmly. Mountains may rise shorter, oceans may curve differently, and every step might feel just a little heavier than on Earth. Every movement requires extra effort, a subtle reminder that the planet exerts a constant, invisible pressure. A simple jump that carries a human several feet on Earth might barely lift a foot off the ground here. Even the rhythm of walking changes, a slow, deliberate motion replacing the light bounce we take for granted. The atmosphere responds to this gravitational embrace as well. Air currents behave differently under the planet's stronger pull, influencing weather in ways we can only guess at. Storms may sweep across the surface with unusual patterns, shaped not just by wind and heat, but by the weight of the planet itself pressing down. Rain and snow, if they fall, hit the ground with a slightly sharper force, reshaping erosion, carving valleys, and smoothing hills in a rhythm unfamiliar to earthbound geologists. Rivers and oceans do not merely flow, they struggle against the gravity that tugs relentlessly at every molecule. Waves crash with a denser weight, tides respond with a precision that seems almost mechanical, and currents wind their way across the planet's surface in patterns dictated by forces we cannot directly observe. Life, if it exists here, must adapt to this constant strain. Creatures might have shorter, sturdier limbs, bones built to resist the ever-present tug, and hearts strong enough to pump blood against a stronger pull. Plants, too, may hug the ground, roots anchored deep to resist being uprooted by the invisible hand pressing down from above. Even time itself feels altered under the weight of Proxima b. Movements take on a more measured cadence, a slight elongation of gestures that makes every moment feel stretched. Energy is spent more quickly, fatigue arrives sooner. To exist here, is to acknowledge gravity not as a background condition, but as a persistent, tangible presence in every action. This is a world that humbles, where the body and mind must constantly recalibrate to the scale of the force pressing from below. And yet, the challenge of gravity carries its own beauty. Mountains, though shorter, rise with a stoic resilience, their slopes steep yet unyielding. Oceans, dense and heavy, move with a silent dignity. The pull of the planet reminds any visitor that they are not in charge, that this world has its own rules, its own rhythm, and its own power. To walk across Proxima b is to walk against a quiet authority, to feel the weight of an entire world in each footfall. It is not merely gravity, it is the planet asserting itself, a force both demanding and magnificent, shaping everything that dares to stand upon it. Here, even the smallest gesture becomes a statement of endurance. Every step, every glance, every heartbeat aligns with a planet far older and stronger than the one we left behind. Proxima b is not a world of ease. It is a world of gravity, and in its grip, we are reminded of the fundamental truth. Every world has its own rules, and to enter them is to surrender, if only briefly, to the pull of something greater. Proxima Centauri is small, but its temper is fierce. It launches powerful flares that can brighten the star by dozens of times in seconds, cosmic heartbeats echoing across space. These eruptions release torrents of radiation and charged particles that surge outward, a relentless reminder that even the smallest stars can wield staggering power. Any world in its orbit, including Proxima b, exists under the constant threat of these stellar tempests, where a single flare can bathe the planet in a radiant storm, reshaping its skies in an instant. The flares are not gentle. They are sudden, violent, and unpredictable. One moment, the sky above Proxima b might glow a steady crimson, bathing the surface in a dim, perpetual twilight. The next, streaks of intense light pierce through the atmosphere, illuminating the landscape with a harsh, almost alien brilliance. The air itself can hum under the influence of charged particles, and electromagnetic surges ripple through the planet's magnetic field, bending compasses, stirring auroras, and, if life exists, challenging the resilience of every living thing. These stellar storms sculpt the environment over time. Atmospheric chemistry shifts under the relentless bombardment, molecules breaking and recombining in ways Earth's air never experiences. Oceans, if present, may feel subtle warming or ionization. Rivers could carry traces of charged particles, and even rocks may slowly bear the scars of radiation etched into their very structure. Proxima b is a planet shaped not only by gravity, but by the capricious mood swings of its star, a landscape molded by bursts of energy that arrive without warning. For any life here, adaptation is not optional, it is survival. Creatures would need shields against radiation, behaviors tuned to the rhythms of the star, and perhaps even biological strategies to repair damage that flares inflict on delicate tissues. Plants or microbial life might retreat beneath protective layers, or develop ways to harness these sudden surges, converting potential destruction into energy. Existence under a red dwarf is a constant negotiation with the heavens, a balance between thriving and enduring, flourishing and merely surviving. The storms also paint the sky in ways unimaginable on Earth. Aurora-like waves ripple across the horizon, coloured in deep scarlets and burning oranges, flickering with the energy of the star itself. Lightning may crackle across charged clouds, a reminder that even distant flares have a reach that stretches across millions of miles. Night and day blend into a continuum of radiant pulses, a celestial rhythm dictated by the temper of a star that seems alive, capricious, and unbound. Yet there is awe in this fury. To witness a flare erupt from Proxima Centauri is to see raw energy made visible, to feel the heartbeat of a star in a way that no telescope can fully capture. The storms are dangerous, yes, but they are also magnificent, a reminder that even the smallest stars leave the largest marks, and that the universe's drama often unfolds not in gentle motions, but in brilliant, fleeting explosions of light and power. Proxima b does not sleep under a calm sky. It exists beneath a star that commands attention, whose flares etch both danger and beauty into the fabric of the world. Here, survival is intertwined with spectacle, and every storm is a story of cosmic ferocity, waiting for those who dare to witness it. These flares can strip atmospheres, bake surfaces, and rewrite the chemistry of planets. Yet they may also spark new molecules, the first notes in the symphony of life. Each burst of radiation carries enough energy to tear apart fragile compounds, breaking molecular bonds, reshaping matter at the most fundamental level. In the blink of an eye, landscapes can be altered, gases ionized, and chemical reactions set in motion that would never occur under calm starlight. Radiation here is both destroyer and creator, a force that sculpts the potential for life as surely as gravity molds mountains. On Proxima b, the atmosphere is under constant siege. High-energy particles slam into gas molecules, dislodging electrons, creating reactive chemicals that swirl and recombine. Oxygen, nitrogen, methane, and other compounds dance under the star's fury, forming new molecules that might serve as precursors to life, or as poisons that challenge survival. Over time, these reactions carve the chemical fingerprint of the planet, an evolving signature written in every drop of rain, in every wisp of cloud, in the layers of rock and ice. The very air seems alive, restless, shaped by invisible hands from millions of miles away. The surface, too, bears the mark of radiation. Minerals fracture under the impact of energetic particles, rocks acquire subtle luminescence, and soil chemistry shifts, laying the groundwork for processes that could eventually feed biological systems. Water, if it exists, may carry dissolved compounds born from these interactions, a primordial soup continually enriched and disturbed by the constant pulse of stellar energy. In this way, radiation becomes a kind of planetary alchemy, transforming raw materials into the potential for complexity. Yet the same radiation that sparks creation can be lethal. Without protection, living cells break apart, DNA shatters, and the most delicate organisms cannot survive long under such bombardment. Life, if it exists here, must either hide beneath layers of rock, burrow deep into oceans, or develop extraordinary resilience. Radiation may dictate patterns of activity, shaping when creatures are active and where they dwell. It sets the rules, enforces limits, and yet, paradoxically, enables the first tentative steps towards something new. There is a strange poetry in this duality. Proxima b is a world where destruction and creation are inseparable, where the star's fury is both threat and opportunity. Every flare, every ionizing pulse, is a reminder that the universe rarely grants calm. It demands adaptation, resilience, and ingenuity. And yet, within this violent rhythm, life may find a way. Radiation, then, is not merely an obstacle. It is a sculptor, a composer, a force that shapes the very possibilities of existence. On Proxima b, the invisible waves that lash the planet may be carving the first lines of a cosmic story, one that begins in chemistry, grows in complexity, and, if the universe allows, blossoms into life. Here, under the relentless light of a tempestuous red dwarf, destruction and creation dance together, and every pulse of radiation writes a new note in the enduring symphony of worlds. Farther out from the star lies Proxima c, a cold, super-Earth, or mini-Neptune, a world frozen in deep shadow, drifting on the edge of the system like a silent sentinel. Unlike Proxima b, it never feels the warmth of the star's close embrace. Its surface, if solid, is hardened by temperatures so low that familiar concepts of liquid water or breathable air are almost meaningless. Ice stretches across continents, and any atmosphere is thin, fragile, perhaps tinged with gases alien to Earth. It is a world that exists at the boundary of light and darkness, where warmth is a distant memory and the pulse of the star barely reaches. In this frozen expanse, time seems to slow. The planet drifts silently, almost motionless in its orbit, as if contemplating the cosmos from the outer edge. Gravity here may be stronger than on Earth, yet the lack of sunlight gives every step a spectral weightlessness. Storms, if they occur, are subtle and slow-moving, shaped by the cold physics of gases rarely found in familiar proportions. Clouds of exotic compounds may drift across a twilight sky, refracting the distant glow of Proxima Centauri into faint, shimmering colors, painting the darkness in tones only a distant imagination could envision. Proxima C's atmosphere, tenuous though it may be, responds quietly to the star's distant flares. Radiation reaches it in whispers rather than roars, enough to slowly alter the chemistry over millennia. Molecules break apart and recombine in patterns no Earth scientist could easily predict, forming new compounds on frozen surfaces or within icy clouds. If life exists, it must do so in ways almost unimaginable, perhaps beneath thick ice layers, warmed by internal heat from the planet's core, or within pockets of briny water that resist the cold. The potential for habitability is limited, yet the planet's silent patience suggests possibility, however hidden. From afar, Proxima C serves as a mirror to its fiery sibling, Proxima B, where B is a world of heat, storms, and relentless energy. C is one of stillness, endurance, and the quiet persistence of ice. Its orbit is a testament to the diversity of planetary existence, a reminder that not all worlds are forged for comfort, that some are sculpted for resilience, surviving on the fringes of light and warmth. Explorers, if they ever reach this distant sentinel, would find a world that challenges imagination. The surface may be alien in every sense: jagged ice cliffs, frozen seas, and skies tinged with hues from atmospheric gases unknown to Earth. Silence reigns here in a way that is almost sacred, broken only by the faint whisper of wind across frozen plains or the subtle glow of distant starlight reflecting off ice. Proxima C is more than a planet. It is a study in contrast, a frozen echo of the star's distant warmth, and a quiet reminder that the universe thrives not only in fury and fire, but also in patience and shadow. A sentinel in the darkness, it waits, unchanging and eternal, a guardian of the outer reaches of a system that hums with the energy of its nearer worlds. Proxima B circles its star in just 11 days. 1 year there is barely more than a long week, time compressed into a cosmic breath. Days and nights, if they exist in any familiar sense, are drawn out or perhaps erased entirely, depending on whether the planet is tidally locked. One hemisphere basks in perpetual warmth, while the other endures eternal shadow. Seasons, as we know them, do not unfold here. Instead, the planet moves through its orbit with a relentless rhythm dictated by the gravity of its star and the invisible hand of motion that governs every celestial body. This rapid orbit has profound effects on the planet itself. Centripetal forces shape the oceans, if any exist, into unusual currents, tugging waters toward the star-facing side while leaving the dark side in relative stillness. Winds circle in patterns dictated not only by heat but by the sheer speed of rotation, bending clouds in ways no Earth sky has ever known. Mountains might rise and fall under stresses unseen on our planet, pulled and pressed by forces that reshape the crust over millennia. Life, if it has evolved here, would have adapted not only to the star's light, but to the pulse of motion itself, attuning its senses to the planet's compressed cycles. Time, as experienced on Proxima B, is a different kind of measurement. A single day might feel endless on the sunlit side, with warmth pouring unbroken across the surface. Yet, in comparison to Earth, a year arrives and passes astonishingly quickly. To age, to grow, to witness change, everything is accelerated. Rivers might carve valleys faster, seasons of growth might flicker and fade in weeks, and the entire rhythm of existence is synchronized with the rapid orbit of the planet around its star. Life, consciousness, and even perception itself would be framed by this condensed march through space. The orbit also places Proxima B in constant exposure to its star's mood swings. Flares and bursts of radiation arrive with astonishing frequency relative to the planet's compressed calendar. There is little time to recover, little respite from the stellar pulses that dictate so much of the planet's environment. The atmosphere absorbs, reflects, or reshapes the energy, but the orbit ensures that no place remains entirely untouched. Survival here requires attunement not just to the planet's surface, but to the rhythm of its celestial journey. Even farther out, planets like Proxima C trace their longer, slower orbits, moving through darkness in stately, deliberate arcs. Their years stretch across decades in human terms, a stark contrast to the rapid dance of Proxima b. Together, these worlds form a complex system, each orbit a note in a symphony of motion, a cosmic choreography that balances gravity, inertia, and light. Proxima b's compressed year is a reminder of the diversity of time in the universe. It is a world where moments are longer and shorter at once, where the pulse of existence is dictated by orbit, and where the passage of time becomes both a measure and a marvel. To live here, or even to imagine living here, is to experience the universe on a scale both intimate and extraordinary. Every orbit a breath, every day a heartbeat, every year a fleeting echo of cosmic motion. Proxima is part of a trio, Alpha Centauri A, B, and Proxima. 3 suns dancing together across millions of years, bound by gravity's ancient embrace. They are a family in the cosmic sense, their orbits weaving a slow, intricate ballet, each star pulling and yielding to the others in a rhythm invisible to the naked eye. To stand on a planet within this system is to feel the tug of distant giants, to sense the slow pulse of gravity stretching across light years, a constant reminder that no star exists in isolation. Alpha Centauri A and B shine brighter than Proxima, their light reaching across the void in steady beams, subtle yet insistent. From Proxima B, they appear as tiny points of brilliance, companions that whisper the history of a system older than human memory. Their motions are slow, almost imperceptible night by night, yet over centuries, their positions shift, tracing ellipses shaped by gravity's patient hand. The 3 stars are entwined not only by force, but by the stories they carry, of formation, collision, and survival in the crowded neighborhood of the Milky Way. This stellar family defines the environment for every orbiting world. Proxima b, huddled close to its small but fiery sun, experiences extreme effects from the flares and radiation of Proxima Centauri. Yet the light of Alpha Centauri A and B adds subtle influences, faint warmth, distant illumination, and gravitational nudges that shape long-term orbital stability. The outer planets, like Proxima C, drift through shadows yet are never fully isolated, subtly guided by the slow, inexorable movements of the system's larger stars. Each planet is caught in a web of motion, a delicate dance that can last for billions of years. To observe the Alpha Centauri family is to witness time on a scale that humbles the imagination. The stars are eternal in human terms, their interactions spanning epochs, their influence shaping planets, atmospheres, and potential life across millions of miles. Patterns emerge only over centuries, yet their effects are profound, imprinting themselves subtly on every celestial body caught within their embrace. The gravitational dialogue between the 3 suns governs tides, axial tilts, and orbital resonances, ensuring that each world follows a path choreographed by forces far beyond human reckoning. There is also a profound beauty in this trio. Each star carries its own personality: Proxima, small and fiery; Alpha Centauri A, golden and steady; Alpha Centauri B, orange-hued and slightly dimmer. Together, they form a constellation of motion and light, a celestial conversation written in orbitals, flares, and radiant warmth. For any observer on Proxima b, these distant suns are constant companions, silent, patient, yet monumental in influence. The Alpha Centauri family reminds us that no star lives in solitude. Every solar system is a story of relationships, of forces seen and unseen, of pasts that stretch into deep time. Proxima, tethered to its larger siblings, is part of a cosmic network, a testament to gravity's reach and the enduring choreography of the universe. In this family, light, motion, and time converge, a dance older than memory, yet still ongoing, still magnificent. From Proxima's perspective, Alpha Centauri A and B would glow like distant lanterns, brighter than any star seen from Earth. They hang in the sky as persistent points of light, steady companions to the fiery flare of Proxima Centauri itself. Unlike the familiar night sky on Earth, which is dotted with countless faint stars, the view here is dominated by these brilliant, distant suns, each a reminder of the system's complexity and the vast scales of cosmic time and space. Even across the millions of miles that separate them, their presence is undeniable, casting faint glimmers of illumination on Proxima's planets, hinting at warmth that barely reaches the outer worlds. Though small, these lights are constant markers in the sky, moving imperceptibly over years. From Proxima B, they do not rise and set like Earth's sun, but drift ever so slowly in their long orbital dance, their positions a testament to the patient pull of gravity. They are twin guardians of the night, reminding any observer of the wider stellar family that binds this system together. Even when Proxima flares violently, painting the planet in harsh reds and oranges, the distant glow of Alpha Centauri A and B remains, a subtle and enduring contrast to the star's fiery temperament. The faint light they cast may not be enough to warm Proxima C or other distant worlds, but it contributes to the overall energy balance of the system. Tides, orbital resonances, and even the trajectories of comet-like bodies feel the distant influence of these twin suns. Their combined gravity sculpts the architecture of the system over millennia, ensuring that each planet follows a path shaped by more than its immediate star. Proxima's planets are never isolated. They exist in a gravitational conversation with their distant siblings, a dialogue written across millions of years. For anyone standing on Proxima B, the sight of these suns would be a surreal experience. In a sky otherwise dominated by crimson hues from their close star, these distant lights would shine like beacons of stability and perspective, a reminder of the broader universe beyond immediate danger. The juxtaposition is poetic, one small, volatile star nearby, flaring unpredictably, and two massive, steady suns in the distance, casting light and influence silently, patiently, across the void. It is a sky that tells a story not just of light, but of time, motion, and cosmic interconnection. Even the faintest light of these distant suns would create subtle effects on the planet's surface and atmosphere. Shadows would be softened, colors muted, and faint reflections could appear on any bodies of liquid or ice. The interplay of Proxima's flare-driven illumination with the steady glow of Alpha Centauri A and B would create shifting patterns of light and shadow. A complex celestial choreography in miniature, revealing the dynamic tension and beauty of a multi-star system. In the end, Proxima's sky is not just a backdrop, it is a living map of forces, a canvas that captures the presence and influence of its stellar neighbors. These two bright suns serve as constant reminders that every world exists within a network of light and gravity, where proximity and distance shape life, environment, and imagination alike. The universe is not empty here. It is a family of stars, a stage on which planets drift and dance, illuminated by both the near and the far. Proxima Centauri is ancient, likely older than the Sun by billions of years. Its worlds have had time to evolve, stories we can only imagine. Time here is not measured in human lifespans, or even in centuries, but in eons, each planet tracing its slow, relentless journey around the star. Mountains rise and erode, oceans form and vanish, atmospheres shift and transform, all while billions of years pass quietly, almost imperceptibly, across the cosmic stage. This system has witnessed more than we can conceive. Countless cycles of change, survival, and transformation before Earth even existed. Proxima B, locked in its close orbit, has endured flares, storms, and radiation for billions of years. Its surface, shaped by gravity and starbursts alike, has likely evolved landscapes that are alien yet familiar in their geological logic. Valleys carved by oceans or rivers long vanished, mountains pressed and reshaped by tectonic forces, and atmospheric layers molded by repeated solar outbursts. Each tells a story written in silence over vast spans of time. Life, if it arose, would have been tested by every extreme imaginable, honed by patience, endurance, and resilience. Farther out, Proxima C drifts in quiet, frozen solitude. Its icy surface and tenuous atmosphere speak of slow processes, of chemical reactions that take millennia to unfold. Any potential ecosystems would have developed in isolation, shaped by the relentless cold and the faint pull of distant stars. Over billions of years, this distant world has accumulated histories invisible to us, layers of ice, traces of chemical evolution, perhaps even signs of microbial persistence hidden beneath its frozen shell. Its silence is not emptiness. It is time rendered visible in frozen stillness, a record of the system's long, patient existence. The Alpha Centauri trio itself moves through time with a steady grace. Proxima, bound to its larger companions, has completed countless orbits around their mutual center of mass. The gravitational interplay has sculpted orbits, nudged planets, and influenced the evolution of every body in the system. These stars are storytellers in their own right, their motions inscribing a record of cosmic history, a tale of survival and equilibrium across billions of years. To imagine this system is to confront the immensity of time. Where Earth's history seems long and vast to us, Proxima Centauri's system is older still, its planets seasoned by epochs far beyond human reckoning. Civilizations, if they arose, might have appeared and vanished unnoticed. Chemical and geological cycles have completed entire revolutions, while humanity was still forming its first tools. Each flare, each orbit, each subtle shift in gravity carries the weight of ages, and every element of the system is imbued with deep history. In the end, Proxima Centauri is more than a star. It is a witness. Its worlds are ancient keepers of secrets, holding stories that may never reach us, yet silently shaping the potential for complexity, life, and evolution. To look at Proxima and its planets is to glimpse a timeline far beyond our own, a reminder that in the universe, age is power, patience is profound, and the histories of worlds extend into dimensions of time we are only beginning to fathom. Because it's the closest star, Proxima is the first destination humanity might ever reach. A gateway to the galaxy, waiting patiently at the edge of our technological dreams. It sits in quiet anticipation, a neighbor just beyond the limits of our reach, beckoning explorers with the promise of discovery and the challenge of distance. For all its proximity, it remains stubbornly out of grasp, reminding us that the universe is vast, and even the nearest suns demand ingenuity, patience, and courage. Proxima is more than a star, it is a threshold. Every photon that leaves its surface travels for over 4 years before it brushes against our instruments, carrying with it the story of flares, storms, and the slow evolution of planets orbiting in its embrace. To reach it is to step across a chasm of time and space, to leave behind the familiar warmth of the sun and venture into a realm governed by different scales of motion, energy, and gravity. The journey itself becomes a measure of human ambition, a mirror reflecting both our limitations and our potential. Its planets, from the searing heat of Proxima b to the frozen silence of Proxima c, serve as the first chapters in a new kind of exploration. They are laboratories of extremes, arenas where life, if it exists, would have adapted to conditions we can barely simulate. Proxima b, with its rapid orbit and fierce stellar flares, teaches us about resilience and adaptation. Proxima c, drifting on the outer edges, demonstrates endurance and patience. Together, they offer a glimpse of the diversity of worlds that exist beyond our solar system, reminding us that every star is a universe unto itself. The crossing to Proxima is also a crossing through imagination. Every probe we send, every telescope we train, every calculation of trajectory and speed is a test of human creativity. We are forced to rethink propulsion, energy, and the very logistics of survival across interstellar distances. Time stretches and compresses in the mind as we plot journeys measured in decades and centuries rather than days and years. Proxima challenges not only our science, but our patience, determination, and vision of what it means to reach outward into the cosmos. Even from afar, Proxima exerts a pull on the human psyche. It represents the first step in a grand migration, the initial note in a symphony of exploration that may one day carry humanity to stars we have only glimpsed in theory. Its proximity makes it a tangible dream, yet the challenges it presents — radiation, gravity, distance — ensure that reaching it remains a formidable test. It is a frontier not yet crossed, a destination that humbles as much as it inspires. Proxima Centauri is a cosmic crossing point, a reminder that exploration begins not with certainty, but with the courage to pursue what lies just beyond reach. It waits at the edge of our understanding, silently offering the first bridge to other suns, other worlds, and other possibilities. To look at Proxima is to look toward the galaxy itself, and to imagine the moment when humanity will finally step across the threshold, leaving the cradle of Earth to touch the nearest neighbor in the vast expanse of stars. Proxima moves through the sky, slowly, steadily, gliding past constellations as centuries pass, a star that drifts but never disappears. Its motion is subtle, almost imperceptible night by night, yet over decades and centuries, the journey becomes clear, a slow testament to the star's place in the galaxy. From Earth, it appears fixed, a pinprick of red light, but in reality, it is traveling, carried by the currents of the Milky Way, tracing an unseen path that speaks of both time and motion on scales humans struggle to grasp. This drift gives Proxima a quiet majesty. Unlike brighter stars whose light dominates our skies, Proxima is understated, an ember glowing steadily in crimson tones, a reminder of endurance rather than brilliance. Its movement across space is patient, a cosmic pacing that has continued long before humanity existed and will continue long after we are gone. There is something deeply poetic about this slow journey, a solitary traveler threading its way through a universe of millions of stars, leaving subtle gravitational ripples that touch planets, comets, and interstellar dust along the way. For the worlds orbiting Proxima, this drift is almost imperceptible, yet it shapes their long-term existence. Over millennia, the star's position relative to its neighbors subtly alters the gravitational influences on its planets, nudging orbits, influencing tides, and affecting the stability of climates. Even the faint light from distant Alpha Centauri A and B, while seemingly constant, interacts with Proxima's slow migration, creating delicate shifts in energy and gravitational balance. The red ember's motion is quiet, but its effects are enduring, a testament to the persistent power of stars in motion. There is a sense of time embedded in this drift that is humbling to consider. While human lifespans measure years, decades, or centuries at most, Proxima's journey unfolds across tens of thousands, millions, even billions of years. Its steady passage reminds us that the universe operates on scales far beyond human comprehension, where the very constellations we recognize shift imperceptibly, and every star has a story written in motion. Observing Proxima is like glimpsing a timeline far older than our history, a cosmic rhythm that continues regardless of our attention. To imagine traveling alongside Proxima is to imagine a journey of quiet awe. The star gliding past nebulae, dust clouds, and neighboring systems is a silent guide through the galaxy, a marker of constancy in an otherwise dynamic universe. Its crimson light, faint yet persistent, illuminates the way for any observer, a visual anchor across the void. Time stretches and compresses as one contemplates its centuries-long drift, revealing the subtle poetry of celestial motion. Proxima, the silent red ember, teaches patience and perspective. Its movement is slow, steady, and inevitable, a cosmic reminder that stars, like time itself, are both enduring and ephemeral. To watch it drift across the sky is to witness continuity, resilience, and the quiet, persistent heartbeat of the galaxy, a steady ember glowing in the vast darkness, never rushing, never fading, always moving forward. Every photon from Proxima is more than 4 years old. To look at the star is to peer backward in time. Each beam has traveled across the dark void, traversing the space between stars at 186,000 miles per second, carrying with it a story of distant worlds and ancient energy. What we see tonight is not Proxima as it is now, but as it was years ago, a snapshot frozen in motion, a memory encoded in light. The photons that strike our eyes or instruments left the star before recent storms, flares, or changes, making every observation a journey into the past. This temporal journey reveals the true scale of the cosmos. Even our nearest stellar neighbor lies so far away that light, the fastest thing in the universe, requires years to arrive. In 4 years, civilizations could rise and fall, planets could evolve subtly, storms could rage and subside, yet we only witness their echoes. Looking at Proxima is, in essence, looking into a history book written in electromagnetic waves. Each wavelength a line of text, each flare or dimming a punctuation in the star's narrative. Astronomy, at this scale, becomes a study not just of space, but of time itself. The delay of light also underscores the challenge of understanding these distant worlds. Observations of Proxima b and c, derived from subtle wobbles and faint shadows, are not instantaneous reports but records of events long past. By the time signals arrive, the planets may have shifted, oceans may have churned, and atmospheric conditions may have altered. Scientists must reconstruct the present from pieces of the past, interpreting ancient light to build models of worlds billions of miles away. The process is an exercise in patience, inference, and imagination, relying on physics and mathematics to translate history into knowledge. Every flare, every pulse of light tells a story. Proxima's violent outbursts, once emitted, travel unceasingly through interstellar space, reaching our telescopes only years later. The star's slow rotation and long-term stability are recorded in the patterns of its light, allowing astronomers to study cycles, magnetic fields, and planetary effects over time. The photons themselves become messengers, carrying data about the star's size, composition, and activity, and whispering clues about the planets that orbit it, including hints of potential habitability or extreme conditions shaped by stellar energy. Ultimately, observing Proxima is an exercise in temporal perspective. Each glance is both immediate and ancient, connecting the observer with events that occurred before the photons even began their journey toward our eyes. It is a humbling reminder that the universe is vast, that stars and planets exist on scales far beyond human experience, and that the act of looking up is also the act of looking back. In its quiet red glow, Proxima Centauri teaches us that to understand the present, we must first read the past, a cosmic archive of light, traveling across space to tell the story of a distant, neighboring star. Proxima is so tiny it will never reach temperatures high enough to fuse helium. Its life is gentle, simple, and unimaginably long. Unlike larger stars that blaze brightly and burn out in mere millions of years, Proxima exists in quiet persistence, simmering steadily for trillions of years, a cosmic candle that will endure long after galaxies have shifted and solar systems have drifted apart. Its energy output is modest, yet sufficient to sustain the worlds that orbit close enough to feel its warmth, creating conditions that may allow for stability, evolution, and perhaps even life over incomprehensibly long timescales. The simplicity of Proxima's fusion process belies its profound impact. Without the violent cycles of helium burning and supernova explosions, it avoids dramatic upheavals that shorter-lived stars impose on their surroundings. Its gentle radiance bathes its planets consistently, flares aside, in a steady crimson light that has persisted for billions of years. For Proxima b, this slow-burning star defines the rhythm of existence, the pace of chemical reactions in the atmosphere, the energy available to any ecosystems, and the long-term evolution of planetary climates. Even the faint light reaching Proxima c carries a subtle warmth, shaping frozen chemistry in ways that might unfold over millennia. In a universe often defined by violence and abrupt endings, Proxima's restraint is extraordinary. It does not rage, it does not explode, it endures. Its modest size and low mass make it stable, reliable, and astonishingly patient. Every photon it emits carries a quiet promise. The stars around it will continue to shine for ages beyond our imagining. Its longevity gives its planets a rare gift in the cosmos. Time to develop, time to stabilize, time for complexity to emerge and evolve without the looming threat of sudden stellar death. This long life also makes Proxima a witness. Across trillions of years, it will observe the slow dance of its companion stars, the orbits of its planets, and the gradual evolution of matter across its system. It will see comets drift, atmospheres form and dissipate, and perhaps even life arise and fall, all while remaining fundamentally unchanged. Its stability is a quiet anchor in a galaxy defined by change, a reminder that not all cosmic drama is sudden or destructive. There is a paradoxical poetry in this tiny star. Its low mass and unassuming light might seem insignificant against the blaze of giants, yet in its endurance lies a kind of grandeur unmatched by even the most spectacular supernova. Proxima exists on scales that challenge human comprehension, a star that measures time not in millennia but in trillions of years, carrying its planets through slow, deliberate evolution under its crimson glow. To contemplate Proxima is to glimpse patience incarnate. It is a star that teaches endurance, quiet strength, and the profound beauty of simplicity. In a universe of fleeting brilliance, Proxima shines gently, persistently, and endlessly, a cosmic testament to longevity, stability, and the patient unfolding of existence itself. Because Proxima is so dim, its habitable zone is squeezed tightly around it, a warm pocket near the star's face, a place where liquid water might whisper across a rocky world. This narrow band of potential life is precarious, a delicate balance between searing heat from flares and the cold embrace of shadow. On Proxima b, it defines where warmth lingers, where chemistry can unfold, and where, if conditions align, life might find a foothold against the relentless pull of gravity and radiation. The proximity of the habitable zone shapes everything about the planet. Orbiting so close, Proxima b may be tidally locked, forever showing one face to the star while the other remains in unbroken darkness. One hemisphere basks in eternal light, a landscape sculpted by warmth and radiation, while the other is frozen in silence, untouched by the star's energy. Between these extremes lies the twilight edge, a narrow band where temperatures are mild enough to allow water to exist in liquid form, flowing, pooling, and perhaps cycling through weather patterns that could sustain life. Life in this zone, if it exists, would have evolved under constant pressure. Radiation flares might lash the sun-facing hemisphere, forcing organisms to develop protection, resilience, or cycles that avoid danger. The dark side would demand adaptation to cold, stillness, and scarcity, perhaps fostering entirely different strategies for survival. The habitable zone is not simply a range of temperatures. It is a crucible that molds biology, a strip of opportunity within a planet of extremes where every molecule of water and every photon of light matters profoundly. The planet's atmosphere plays a crucial role in this fragile balance. It redistributes heat, moderates flares, and allows for chemical reactions essential to sustaining life. Clouds may form and drift along the terminator, the line between day and night, creating dynamic weather that carries moisture, energy, and nutrients across the planet's surface. In this narrow belt, life would not just survive, it would dance with the forces of its environment, responding to light, gravity, and radiation in ways impossible on Earth. The habitable zone around Proxima is a lesson in intimacy with a star. Unlike Earth, where warmth and light are abundant across vast distances, here, everything depends on precise proximity. A slight shift in orbit could plunge the planet into freezing darkness or scorch it with unrelenting energy. To exist within this zone is to embrace a delicate equilibrium, a cosmic dance that balances risk and reward, destruction and possibility, heat and shadow. In the end, this tight habitable zone transforms Proxima b into a world of contrasts, one of fire and ice, light and shadow, danger and opportunity. It is a place where water might trace its first paths across rocky terrain, where life, if it arises, would be intimately tuned to the rhythms of its star. The habitable zone is not just a measure of distance, it is the heartbeat of potential, the narrow stage on which the first chapters of life could play out under the quiet, persistent gaze of a dim, ancient star. Proxima's stellar wind blows strongly, shaping magnetic fields and sculpting the atmospheres of nearby planets, whispering through the void like an unseen breeze. These winds carry streams of charged particles that ripple across space, tugging gently at magnetic fields, eroding atmospheres, and carving invisible trails that stretch for millions of miles. They are the silent exhalations of a star, subtle yet relentless, shaping everything in their path and reminding any nearby world that even the emptiness of space is alive with motion and energy. On Proxima b, this wind is both a force and a presence. Its atmosphere, tenuous and fragile, responds to the ceaseless push of particles, generating auroras that flare across the sky in fleeting brilliance. The magnetic field of the planet, if strong enough, bends and redirects these cosmic currents, creating patterns of light and shadow that dance across the surface. To stand under such skies, if one could survive the radiation, would be to witness a silent song of energy, a cosmic melody composed by invisible forces flowing from the star itself. The wind also acts as a sculptor over longer timescales. Atmospheric molecules are stripped, recombined, and redistributed, altering the chemical makeup of the planet's envelope. Oceans, if present, feel subtle nudges, while clouds are stirred in unusual patterns dictated by magnetic interactions. The wind is not merely a background effect, it is a dynamic player in the evolution of the planet, shaping climates, weather, and potentially even the paths of life. Each gust, each pulse, is a reminder that proximity to a star is not just exposure to light, it is immersion in a living, moving system of forces that operate beyond sight and sound. Beyond Proxima b, the wind stretches across the system, interacting with Proxima c and any smaller, more distant bodies. Its influence diminishes with distance, but never entirely vanishes. Even the faintest particles carry energy and momentum, nudging dust clouds, comets, and charged gas through the interstellar neighborhood. Over eons, these cosmic winds sculpt the architecture of the system itself, a quiet hand guiding matter in subtle, persistent ways. There is a strange beauty in this invisible motion. The wind is imperceptible to human senses, yet it orchestrates a complex symphony of interaction between star, planet, and magnetic field. Its effects are felt rather than seen. A shifted orbit, a glowing aurora, a changed chemical balance. It reminds us that stars are not passive lights in the sky. They are active, living entities, breathing energy across the void, shaping everything that comes near. Proxima's cosmic wind is a voice that sings through space, a gentle but persistent force that carries the star's presence far beyond its surface. It is both destructive and creative, eroding, shaping, and sustaining. A subtle rhythm that binds star and planet, energy and matter, in a dance that unfolds silently yet powerfully across the galaxy. To encounter it, even in imagination, is to feel the living pulse of a star reaching across the void, a quiet song that continues endlessly, shaping worlds and whispering secrets of the cosmos. Even at noon on Proxima b, daylight might feel like late evening on Earth, a dim, dusky brightness that softens every landscape. The star's light, faint and crimson, bathes the world in muted tones, transforming familiar concepts of color and contrast into something almost alien. Shadows stretch long and blend seamlessly with the surrounding terrain, and details that would leap out under Earth's sun are softened into gentle contours. The planet exists in a perpetual twilight, where the brilliance of daylight is tempered by the quiet persistence of a small, ancient star. This subdued illumination shapes everything on the planet's surface. Vegetation, if it exists, would absorb and respond to red wavelengths, evolving pigments different from the greens we know. Shadows cast by mountains and ridges would dominate the landscape, creating dramatic contrasts between the sunlit side and the twilight edge. Even the oceans, if liquid, would reflect a muted glow, turning waves into pools of deep crimson or dark maroon. The light of Proxima B's star is not harsh, it is gentle, but insistent. A constant companion that governs the rhythm of life, weather, and the passage of time. Time itself is measured differently under such illumination. The subtlety of light changes, the slow dimming and brightening caused by flares or atmospheric shifts, would dictate the cycles of activity for any living creatures. Days might feel long despite their brief orbit, as the sun-facing hemisphere bathes in persistent but soft red light. Nights are not stark black, but a continuation of the dusky hue, a transition rather than an absence, where even the shadowed side retains faint traces of illumination from scattered starlight or distant Alpha Centauri A and B. The planet's atmosphere plays a crucial role in moderating this light. Clouds, dust, and haze scatter the crimson photons, creating diffuse illumination that can stretch for thousands of miles. Dawn and dusk merge into a continuous gradient of red, a soft glow that emphasizes texture over brightness, shape over color. Mountains, valleys, and ice flows are rendered in delicate tones, and even the smallest ripple of water or gust of wind carries subtle shadows that shift imperceptibly with time. Yet this dimness is not a limitation. It is a defining characteristic, a stage upon which the drama of the planet unfolds. The light of Proxima teaches resilience. Life must thrive under a sun that never blazes, adapting to constant twilight, to subtle cues and quiet changes. It is a world of understated beauty, where the smallest shift in illumination transforms perception, and where every photon carries significance. To experience daylight on Proxima b is to experience a planet that exists in gentle contrast, softened by distance, shaped by a star too small to flood its world with brilliance. It is a place where dim light guides life, where color and shadow take on new meaning, and where the universe reminds us that even the faintest star can define a world in ways both subtle and profound. With such faint light, shadows on Proxima b might grow long and surreal, stretching across landscapes like dark ribbons. Mountains cast exaggerated silhouettes, their peaks and ridges melting into the soft crimson glow of the star. Valleys, cliffs, and plains are transformed by these elongated shadows, creating patterns that shift subtly with every flare, every movement of clouds, and every ripple across oceans, if they exist. The world is a place where light and darkness mingle in a constant, slow-motion dance, blurring the line between day and night, presence and absence. The shadows themselves are more than visual phenomena. They define the planet's rhythm. The terminator, the line between the perpetual day side and the eternal night side, stretches in a narrow band where shadows are longest and most dramatic. In this zone, the interplay of light and darkness creates a world of contrasts. A twilight corridor where temperatures might moderate and where liquid water, if present, could flow. It is here that the faint illumination interacts with gravity, wind, and terrain to craft landscapes of stark beauty and hidden complexity. A stage for life or geology, sculpted by extremes. Life, if it exists, would be intimately attuned to this interplay of shadow and light. Organisms on the sunlit side must contend with bursts of radiation and uneven heat, while those near the twilight edge navigate subtle gradients of light and warmth. Shadows may serve as shelters, cooling refuges, or hiding places. Photosynthetic life, if it has evolved, would rely on every photon, harvesting energy from the dim crimson glow and adapting to the elongated patterns of shade. In this environment, the contrast between dark and light is not merely aesthetic. It is survival, guiding movement, behavior, and growth across a landscape where the faintest light carries profound consequences. Even inanimate features of the planet are transformed. Frozen ice flows, rocky ridges, and cratered plains catch the dim light in ways that exaggerate texture and depth. Shadows stretch across oceans or lakes, subtly moving with the flow of currents or shifting winds. The planet's topography, magnified by low illumination, gains a dreamlike quality, a surreal, otherworldly character that would be impossible under Earth-like sunlight. Every step across the surface, every glance at the horizon, would reveal new details in the interplay of form and shadow, creating an ever-changing panorama of muted contrasts and delicate intricacies. The long shadows also highlight the intimate relationship between Proxima b and its star. Each flare briefly alters the patterns, shortening or brightening shadows, a fleeting reminder of the star's presence and power. Between flares, the shadows stretch back into slow-motion eternity, a visual echo of the planet's compressed year and the slow, patient drift of the system through space. On Proxima b, shadows are not merely absences of light. They are sculptors, guides, and storytellers. They stretch forever across the crimson landscape, painting the planet in patterns of mystery, beauty, and subtle drama. The faint light of a small, ancient star gives rise to a world where darkness and illumination are inseparable, shaping everything from terrain to potential life, and reminding any observer that even the softest light can create the most profound silhouettes. If Proxima b has a strong magnetic field, it may protect its atmosphere from stellar storms, a shield against the star's wilder moods. This invisible force, generated deep within the planet's core, could deflect charged particles hurled by flares, preserving the air, water, and delicate chemistry necessary for life. Without it, the atmosphere might be stripped away over time, leaving the surface exposed to relentless radiation and the harsh vacuum of space. With it, Proxima b might endure. A fragile oasis cradled in the gentle protection of magnetic currents. The magnetosphere would shape the planet in ways both subtle and profound. Charged particles from Proxima Centauri would spiral along magnetic lines, converging at the poles to create auroras that glow faintly in crimson and green, painting the sky with luminous ribbons. These shimmering displays are not mere beauty. They are evidence of the planet's protective embrace, a visible manifestation of a force that safeguards every molecule of air, every drop of water, and potentially every organism that depends on them. The magnetic shield transforms the planet from a place of vulnerability into one of resilience, a quiet defense against a star that is otherwise volatile and dangerous. Beneath the surface, the magnetosphere might influence geological and chemical processes. Electric currents induced in oceans or metallic cores interact with the field, generating heat, circulation, or even subtle tectonic effects. The atmosphere, guided and constrained by magnetic lines, forms patterns that buffer the impact of flares, spreading energy more evenly and reducing destructive peaks. Winds, clouds, and weather systems are subtly shaped by this protective envelope, creating a more stable environment than might otherwise exist on a planet so close to its tempestuous star. For life, the magnetosphere is more than a shield. It is a framework for possibility. It allows molecules to persist long enough to interact, recombine, and form increasingly complex chemistry. It gives oceans a chance to remain liquid, prevents radiation from mutating biological structures beyond repair, and creates regions of safety where ecosystems could take hold. Any life on Proxima b would owe its existence, in large part, to this unseen guardian, which quietly endures as the star flares and storms rage around it. The magnetic field also connects the planet to the star in an intimate way. Energetic particles funneled along field lines interact with the atmosphere, sparking auroral dances and driving chemical reactions that might contribute to the formation of prebiotic molecules. Here, protection and creation are entwined. The very field that shields also guides the energy of the star into forms that can foster life, turning violent stellar moods into instruments of planetary evolution. Ultimately, a strong magnetosphere transforms Proxima b from a precarious, storm-battered world into a realm of potential. It is the invisible armor that grants the planet stability, a quiet but profound force that mediates between danger and possibility. On this small, crimson world, the magnetic field is not just a defense, it is a lifeline, a silent protector, and a subtle shaper of everything that endures beneath the watchful eye of a small, ancient star. Proxima b and c may interact gravitationally, creating a delicate rhythm, a cosmic duet that shapes their stability. Though separated by vast distances relative to their own sizes, the pull each exerts on the other is subtle but persistent, a gentle tug that keeps both worlds in a carefully choreographed motion. Over millennia, these gravitational interactions align their orbits in patterns of resonance, ensuring that neither strays too far or too close, that chaos is avoided and balance is maintained. It is a silent dance, governed by the immutable laws of physics, yet so intricate that even the slightest variation could ripple through the system. This orbital duet influences much more than position. On Proxima b, the gravitational nudge from its distant sibling could affect tides, tectonics, and perhaps even the climate. Oceans, if they exist, rise and fall not solely in response to a sun, but in a slow, resonant rhythm dictated by the tug of a faraway companion. Mountains and crustal plates experience subtle stress, slowly shaped over eons by these invisible forces. Even the atmosphere responds, with wind patterns and cloud formations subtly guided by the shifting pull of gravitational resonance. The planet itself is molded not just by its star, but by the cosmic conversation with its companion. Proxima c, distant and cold, is similarly influenced. Though it drifts through shadowed extremes, the periodic pull from Proxima b ensures that its orbit remains stable, preventing the chaotic wandering that could destabilize the system. Over billions of years, this gravitational coupling preserves order where randomness might otherwise reign, allowing both worlds to persist through the violent potential of stellar flares, orbital shifts, or encounters with interstellar objects. Their resonance is a stabilizing rhythm, a celestial heartbeat marking the passage of time in the system. The beauty of this dance lies in its subtlety. It is not violent or overt, no explosions, no collisions, only the quiet language of motion and pull. Over centuries, decades, or even days, the changes are imperceptible. Yet over millennia, the effects accumulate, shaping landscapes, climates, and perhaps the evolution of life itself. The planet's paths are entwined, locked into a pattern that reflects both their individuality and their connection, a cosmic choreography of immense precision and enduring stability. For any observer standing on Proxima b or c, the effects of this orbital resonance would be largely invisible to the eye, yet profound in consequence. The rhythms of tides, the stability of seasons, the pacing of geological and atmospheric processes, all are subtly dictated by the gravitational whispers exchanged between the two worlds. It is a reminder that planets are not solitary travelers. They are participants in an intricate ballet of mass, motion, and momentum. In the end, the resonance between Proxima b and c is more than orbital mechanics. It is a story of balance and harmony, a cosmic duet played over billions of years, shaping worlds in ways both visible and hidden, preserving stability amid the chaos of space, and demonstrating that even in the silent vacuum of the cosmos, motion is music, and every orbit is part of a grand, intricate symphony. Tides on Proxima b could be immense, shaping oceans into patterns far more dramatic than those on Earth. The planet's close orbit around Proxima Centauri means that the star's gravitational pull exerts constant, intense influence on any liquid surfaces. Oceans, if they exist, are stretched and compressed with each rotation, rising in colossal bulges on the star-facing side and along the terminator, while retreating into deep troughs on the night side. The ebb and flow of water here is not subtle. It is a planetary heartbeat, a visible rhythm that sculpts coastlines, carves channels, and drives the movement of sediments across vast distances. The tidal forces extend far beyond simple water movement. They affect the planet's crust and mantle, generating stresses that could fuel tectonic activity, earthquakes, and volcanic eruptions. Mountains might grow taller or fracture more quickly under the strain. Valleys could deepen, and the overall geology of the world is continually reshaped by the push and pull of its close star. These tidal rhythms act as a planetary engine, influencing not just the surface but the very structure of Proxima b, creating a dynamic, ever-changing landscape that is alive with motion. The tidal pull also impacts the atmosphere. As oceans swell and shrink, winds shift, carrying moisture along vast distances and creating weather patterns unlike anything on Earth. Storms may be driven by the uneven heating of the star-facing hemisphere, while the dark side remains eerily calm, yet still feels the gravitational tug transmitted through the planet itself. Clouds form, drift, and dissipate in ways dictated by tides as much as temperature, creating skies that are constantly in flux, with subtle interactions between gravity, wind, and light shaping the climate. For life, if it exists, these tidal extremes are both challenge and opportunity. Coastal ecosystems, if they have developed, must adapt to oceans that rise and fall with extraordinary intensity. Chemical mixing caused by tidal surges could foster nutrient cycles that promote biological activity, while calmer zones along the twilight band may provide refuge. Even on the sun-facing hemisphere, tidal forces could create pockets of liquid water, temporarily safe from radiation and flare-driven extremes. Life here would be intimately tied to the planet's heartbeat, evolving in step with the immense pull of its star. Viewed from space, Proxima b's tides would make the planet appear almost alive. Oceans glowing faintly in the crimson light would bulge and recede in synchronized motion, waves reflecting flares and shadows alike. The contrast between the illuminated hemisphere and the dim twilight would be accentuated by the shifting water, a constant reminder of the star's strength and the intimacy of its grip. Ultimately, the tidal pull of Proxima Centauri is a defining feature of its closest planet. It is a force of creation and destruction, shaping geology, climate, and potential life alike. On Proxima b, gravity is not invisible. It is a sculptor, a conductor, and a relentless artist. A ceaseless dance under the crimson gaze of a small, ancient star. Even if Proxima b lost its surface atmosphere, life might hide beneath layers of ice, warmed by geothermal heat and chemical reactions. Beneath the frozen exterior, oceans could persist in liquid form, insulated from the harsh radiation of a volatile star and the vacuum of space. These hidden seas would be dark and quiet, a refuge where chemistry continues its slow work, and where life, if it exists, could evolve in isolation. The surface may be inhospitable, yet beneath the ice, the planet might harbor entire ecosystems, shielded from the storms and flares above. Geothermal energy becomes a lifeline in such an environment. Heat from the planet's core would percolate upward, melting pockets of ice and creating currents that circulate nutrients. Chemical gradients form along these flows, providing energy for reactions that could sustain life. Hydrothermal vents, similar to those on Earth's ocean floors, may exist, spewing mineral-rich water into subterranean oceans, creating islands of chemical complexity. In these hidden depths, life would not rely on sunlight but on the slow alchemy of chemistry, electricity, and heat. A different kind of biosphere, resilient and self-contained. The ice itself is not merely a barrier, it is a protective shield. Tens of meters of frozen surface block harmful stellar radiation, reducing the impact of flares and cosmic wind. Beneath this frozen crust, water remains stable, maintaining pressure and temperature within a range suitable for complex chemistry. The ice might crack and shift, allowing exchange of gases or minerals between surface and subsurface oceans, a subtle communication between the exposed and hidden layers of the planet. Life beneath the ice would adapt to the darkness, evolving senses, behaviors, and metabolisms that exploit the narrow range of energy available. These subsurface seas also offer insight into planetary resilience. Even on a world scorched by flares or stripped of atmosphere, life could persist out of sight, hidden from view, but still active. They remind us that habitability is not always obvious. It may be concealed beneath layers of ice, waiting for the right conditions to be revealed. On Proxima b, Such oceans would represent a stubborn persistence of possibility, a quiet testament to the ability of life to endure where conditions are extreme. From afar, these hidden oceans are invisible, but their presence is written in subtle clues, thermal anomalies, faint magnetic interactions, and the chemistry of escaping gases. For explorers or observers, they hint at worlds that are alive even when they seem dead, demonstrating that life need not follow Earth's familiar blueprint. Subsurface seas expand the definition of habitability, showing that even the most hostile surfaces can conceal havens of vitality beneath. Ultimately, the possibility of subsurface oceans on Proxima b is a story of hidden endurance. Ice and darkness become allies rather than obstacles. Chemistry and heat provide energy where sunlight cannot. And life, if it exists, adapts to a world of extremes. Beneath the red star's faint light, beneath frozen landscapes and violent flares, secret seas may flow quietly, keeping the pulse of life alive in the planet's hidden depths. Charged particles from Proxima's flares might create auroras brighter than Earth has ever known. Curtains of color shimmering in permanent twilight. Unlike the soft greens and occasional reds that dance across Earth's polar skies, these auroras would blaze in shades of crimson, deep magenta, and even flickering violet, painting the sky in surreal, otherworldly patterns. The flares themselves act like cosmic brushes, sending streams of energized particles spiraling along magnetic lines, igniting the upper atmosphere in brilliant, shifting displays. On Proxima b, the auroras would be constant companions, a luminous echo of the star's volatile temperament. The scale of these auroras would be immense. With Proxima's proximity and flare intensity, curtains of light could stretch from horizon to horizon, cascading over mountains and oceans alike. They would pulse in rhythm with the star's activity, intensifying during flares and softening during quieter periods, creating a dynamic, living tapestry in the sky. Unlike Earth, where auroras are often fleeting, these displays could last for hours or days, bathing the planet in light that is both beautiful and potentially dangerous, reminding observers of the star's persistent energy. The auroras would interact with the planet's magnetic field, highlighting the invisible architecture that shields the surface from stellar storms. Magnetic lines channel particles toward the poles, producing concentrated bursts of light in predictable patterns, yet the sheer intensity of Proxima's flares could make the auroras unpredictable, streaking across the sky in chaotic brilliance. The dance of color is therefore both structured and wild, a visual representation of the complex interplay between star, planet, and magnetic force. Beneath these curtains of light, the surface would feel transformed. Shadows stretch and twist, valleys glow faintly in reflected auroral illumination, and even oceans shimmer in response to the charged particles. The atmosphere itself becomes a medium for art and science, where physics paints with energy, and every flare reshapes the sky in vivid, fleeting compositions. For any life present, these auroras could influence behavior, migration, or even biological cycles, as creatures adapt to the constant rhythm of light and energy. From space, the auroras would be a spectacle visible across millions of miles, marking Proxima b as a world alive with magnetic and stellar interactions. Satellites, probes, or distant observers would see a crimson halo circling the planet, a signature of its magnetic shield and atmospheric dynamics, a celestial signature of a planet shaped by extremes. The auroras are not just decoration, they are evidence of energy flowing through the system, a visible pulse of the star's influence on its closest companion. Ultimately, the alien auroras of Proxima b are a reminder that light in the universe takes many forms. Under a dim, red sun, the skies become a living canvas, where particles and magnetism paint displays far beyond Earth's imagination. These luminous curtains are both beautiful and revealing, a constant testament to the forces that shape the planet, the subtle protections that allow life to persist, and the awe-inspiring spectacle of a world under the gaze of a star that is at once gentle, ancient, and ferociously alive. When the Milky Way is old and dim, red dwarfs like Proxima will still shine on, the final lanterns of a fading galaxy. Long after massive stars have exploded, scattered their material, and faded into cold remnants, Proxima and its kind will persist, burning steadily, quietly, and almost eternally. Their light is modest, crimson, and unassuming, yet it will endure for trillions of years, outlasting the brilliance of younger, hotter stars and serving as a lingering witness to the history of the cosmos. In the distant future, when galaxies themselves have drifted into silence, Proxima's glow will remain, a beacon in a darkening universe. Planets orbiting these steadfast stars may continue to host chemistry, liquid water, and even life, long after the grand fireworks of stellar evolution have ended elsewhere. Red dwarfs are cosmic survivors, slow, patient, and enduring, immune to the rapid burning and catastrophic deaths that define the lifetimes of giants. They are the quiet elders of the stellar community, outliving stars that once seemed mighty, yet now rest as cold remnants scattered across the galaxy. Proxima's longevity shapes the story of its planets as much as its light. On Proxima b, the same stability that allows flares to dominate also grants periods of calm, with the star's persistent warmth providing a long window for geological, chemical, and potentially biological evolution. Even Proxima c, distant and cold, orbits a star that will continue to emit energy far longer than any human civilization or solar system could ever hope to witness. In this way, the red dwarf becomes not only a lamp in the darkness but also a slow, steady sculptor of worlds, preserving the conditions for persistence where more volatile stars might have destroyed them. The universe itself changes dramatically during this long lifespan. Spiral arms fade, galaxies collide and merge, and the stars that once lit the night sky vanish one by one. Yet Proxima remains, a crimson sentinel, quietly burning in defiance of cosmic entropy. Its photons will travel farther, longer, bearing the record of its quiet existence to whatever observers or instruments may still be capable of detecting them in the far future. The star becomes a measure of cosmic patience, a standard of endurance in a universe defined by impermanence and transformation. There is a profound poetry in this longevity. To consider Proxima is to consider time on scales far beyond human imagination. Here is a star that outlives all others, whose endurance transforms our understanding of what it means to shine. Its planets, its light, and its magnetic and gravitational influences are all tied to this extraordinary persistence, a reminder that not all cosmic forces are fleeting. Some endure patiently, quietly shaping the universe long after everything else has faded. In the end, Proxima is a symbol of cosmic resilience. While the universe dims around it, this red dwarf continues to burn, a final lantern illuminating the galaxy, a star that endures beyond the lifespan of most, and a silent witness to the slow unfolding of time across billions and trillions of years. Its light is modest, yet eternal, a quiet promise that even in the darkest reaches of space and time, endurance and persistence remain possible. Proxima's long life means its planets have experienced more stellar history than Earth, billions of years of cosmic weather, chemistry, and evolution. Every flare, every pulse of light, every gust of stellar wind has left a mark, etched into the rocks, oceans, and atmospheres of its worlds. Proxima b and c are living archives, their surfaces and subsurfaces holding a record of processes that span epochs far longer than the 4.5 billion years that have shaped Earth. To study them is to peer into a history written in the language of energy, gravity, and chemistry, a narrative that begins long before humans even existed. This deep record is not uniform or simple. Proxima's flares may have stripped or altered atmospheres, sculpting chemical compositions, while the tidal forces from its close orbit could have reshaped continents or frozen oceans. Subsurface seas, if they exist, would preserve a steady history, buffered from sudden change, recording subtle shifts in temperature, chemistry, and perhaps even the footprints of life. Each layer of ice, rock, or liquid is a page in an ancient diary, chronicling the interaction of star and planet across timescales that challenge human imagination. The chemical imprints of this long history are profound. Flares and cosmic wind bombardments create molecules not found on Earth, rearranging elements, sparking reactions, and forming the building blocks of potential life. Over billions of years, this slow alchemy could yield complex prebiotic chemistry, even in environments far from the ideal conditions of Earth. The surface may bear scars of radiation, impact craters, or altered mineral deposits, each one a historical event in a timeline stretching into the trillions. The very air and water, if they exist, carry the faint echoes of Proxima's relentless energy output, a whisper of its ancient pulse. Studying such a world is like reading the universe's memoirs. Each aurora, each tidal rhythm, and each magnetic interaction contributes to the record, documenting how a small red star shapes its planets over unimaginable durations. Proxima's planets, if observed carefully, reveal how life, weather, geology, and chemistry unfold when given far more time than Earth has ever experienced. They are natural laboratories of endurance and adaptation, offering a perspective on processes that evolve slowly and persistently, beyond the fleeting scales familiar to humans. This ancient light has also guided evolution, if life has arisen, providing a constant, low-level energy source across billions of years. It is a persistent presence, a red glow that illuminates history itself, stamping every molecule and rock with evidence of a star that endures. Proxima's planets thus become not just worlds, but chronicles of time, fossilized in their chemistry, structure, and dynamics. Ultimately, Proxima's system is a living fossil record, a testament to the power of time and persistence. Its planets have endured stellar storms, tides, and radiation for longer than Earth has existed, preserving a narrative written in light, gravity, and chemistry. To explore them is to step into the annals of cosmic history, reading the story of a star and its worlds across billions of years. A record older, stranger, and more enduring than anything we can find in our own solar system. If advanced civilizations exist, red dwarfs are ideal hosts. Their long lifetimes offer stability for projects that span millennia. Unlike massive stars that burn brightly and die quickly, red dwarfs like Proxima persist for trillions of years, providing a steady source of energy that could sustain civilizations far longer than Earth has existed. For a species capable of engineering on a cosmic scale, these stars offer the promise of permanence, a chance to build structures, harvest energy, and explore technology without fear that the host star will perish before their ambitions are realized. Consider the possibilities. Megastructures such as Dyson swarms, orbital habitats, or energy harvesting arrays could be constructed over centuries, decades, or millennia, taking advantage of the steady, long-lasting light of a red dwarf. The low luminosity of the star means structures could be built closer to the star than around a sun-like star, potentially making energy collection more efficient and orbital mechanics simpler. Civilizations could optimize their architectures around the star's dim, persistent glow, creating networks of habitats, laboratories, or even planetary-scale terraforming projects that endure for generations, centuries, or millennia. The extended stability of red dwarfs also allows for experimentation and evolution of technology at a scale unimaginable for civilizations around shorter-lived stars. Projects could be planned with patience, and trial-and-error approaches could unfold over vast timescales. Proxima b, with its close orbit, tidal locking, and magnetic field, could be a testing ground for advanced environmental management, controlling climate, shielding from radiation, or harnessing tidal energy. Proxima c, colder and more distant, might host orbital or subterranean facilities, shielded from flares, serving as long-term refuges or laboratories. The system's resonance and predictable orbital dynamics make it an ideal setting for coordinated engineering on a planetary or interplanetary scale. Even the challenges presented by the star's flares, magnetic storms, and cosmic winds could be harnessed creatively. Advanced civilizations could convert these energetic events into resources, collecting charged particles, driving chemical reactions, or generating electricity through magnetohydrodynamic systems. What appears as danger to a simple organism becomes raw material for a civilization that understands the laws of physics and the rhythms of its star. In this sense, Proxima's volatility is not a limitation, but an opportunity for ingenuity and long-term planning. The concept extends beyond survival. A civilization capable of megastructures around a red dwarf could manipulate its system in ways that last far longer than human history. It could shape light, heat, and magnetic fields to sustain life, create habitable zones across planets or moons, and leave a signature of its presence that endures across cosmic time. Proxima becomes not just a star, but a partner in civilization building, its longevity providing the canvas upon which ambition can unfold uninterrupted. Ultimately, red dwarfs like Proxima represent more than energy sources. They are platforms for the imagination, for technology, and for civilizations that think in millennia rather than decades. Their persistence transforms them into ideal candidates for megastructures, long-term habitats, and projects that stretch the very concept of time. In the quiet red glow of Proxima, one can imagine futures shaped not by fleeting ambition, but by patient, enduring purpose. Civilizations building on a foundation as steady and eternal as the star itself. A tidally locked orbit means no tilt, no seasons, just endless warmth on one side and eternal cold on the other. Proxima b is locked in a cosmic embrace with its star, always showing the same face to Proxima Centauri. The day side is bathed in perpetual crimson light, a realm of constant illumination where heat and radiation persist unrelentingly. The night side, conversely, is frozen and dark, untouched by the star's energy, a shadowed expanse where temperatures plummet and winds carry the whisper of absence. This lack of seasonal change creates a planet of extremes, a world defined not by cycles but by permanent contrast. Between these two poles of temperature lies the twilight band, a narrow terminator where day meets night. Here, conditions might be mild enough to allow water to remain liquid, forming rivers, lakes, or even seas along the boundary. This zone becomes the planet's most habitable region, a strip where temperatures and energy inputs are balanced. Life, if it has arisen, would be forced to concentrate here, adapting to the gradient of light and heat. The rhythm of existence would not follow seasons, but the stable, relentless cycle of tidal locking, a steady pulse dictated by proximity to the star. Weather on such a world behaves differently from Earth. On the day side, air rises continuously from heated surfaces, forming persistent updrafts that feed clouds and storms. Winds flow toward the night side, carrying heat and moisture along the terminator, only to sink back toward the cold, dark hemisphere. Without seasonal shifts, climate is determined by geography, local heating, and stellar energy alone. Storms may flare up in response to flares from Proxima, creating dramatic weather events that are sudden and intense, yet repeatable in a way that marks the planet's constant rhythm rather than a yearly cycle. The absence of seasons also affects the planet's ecology, if life exists. Organisms would evolve strategies for a world of permanent extremes, with some thriving under continuous light, others adapting to the darkness, and perhaps only a few finding ways to exploit the twilight margin. Biological clocks would not follow annual cycles, but rather the subtle, steady signals of temperature gradients, magnetic fluctuations, and tidal rhythms. Life here, if present, would be intimately connected to place, bound by geography more than time, and by light more than calendar. Geologically, tidal locking imposes its own patterns. The star-facing hemisphere may experience thermal expansion, creating stress fractures, volcanic activity, and reshaping terrain over millennia. The night side, cold and rigid, could accumulate ice sheets or frozen landscapes, while the terminator acts as a zone of slow erosion, chemical interaction, and gradual change. In essence, the planet is carved by its eternal division between heat and cold, light and shadow, a place where permanence is the defining law. Ultimately, Proxima b's tidally locked orbit creates a world without seasons, a planet of extremes and contrasts. Endless day and endless night define its landscapes, climates, and potential life, shaping a rhythm that is steady, predictable, and starkly different from the cycles we know on Earth. Here, the passage of time is felt not in spring or fall, but in the subtle interplay of warmth, cold, and the narrow band that links them. A world governed by balance rather than change, by persistence rather than variation. Between light and darkness lies a band of perpetual dusk, the terminator zone, a place where conditions might be just right for life. Here, the extremes of Proxima B's tidally locked orbit meet, creating a narrow corridor where heat from the day side and the frigid darkness of the night side converge. Temperatures moderate along this line, allowing water to remain liquid, clouds to drift gently, and winds to circulate steadily between light and shadow. It is a zone defined by balance, a narrow ribbon of potential habitability wrapped around a planet of extremes. The terminator zone is a place of constant contrast. One horizon glows with the soft crimson of Proxima Centauri, illuminating rocks, mountains, and oceans in muted light, while the opposite horizon disappears into permanent darkness, a black expanse stretching endlessly. Shadows here are elongated and surreal, folding across the terrain in ways impossible under Earth's sun. Valleys and cliffs, rivers and lakes are all sculpted by the interplay of thermal gradients and persistent winds that flow along the twilight line, creating landscapes of subtle motion and quiet drama. Weather in the terminator zone is unique. Air rises continuously from the warm side and descends into the cold, driving constant circulation that carries moisture and heat along the band. Storms may form and drift predictably. Unlike the chaotic systems of Earth, yet flare-driven bursts from Proxima can intensify them suddenly. Clouds glow faintly in red light, reflecting auroral displays, flares, and scattered photons, creating a sky that is simultaneously dynamic and gentle. The terminator zone is a place where light, wind, and water converge in equilibrium, sculpting a delicate and stable environment. Life, if it exists, would find the terminator zone irresistible. Organisms might cluster here, evolving strategies to exploit gradients of temperature and illumination. Photosynthetic life could harvest the dim red light, while creatures in the cooler regions could retreat into darkness to avoid radiation or heat extremes. Every organism would be tuned to the rhythms of the star, the magnetic field, and tidal forces, responding to subtle shifts rather than dramatic seasonal cycles. This band becomes not just a habitat, but a corridor of opportunity, a narrow margin where survival is possible and stability prevails. Geologically, the terminator zone is also a place of slow but persistent change. The constant stress between hot and cold hemispheres can fracture rock, drive tectonic activity, and reshape coastlines and riverbeds over millennia. Ice from the night side may slowly melt as it drifts toward warmth, feeding liquid reservoirs, while erosion and deposition sculpt new features. In this way, the zone is alive with motion, a subtle theatre of energy, matter, and chemistry, balanced on the knife edge of light and shadow. Ultimately, the terminator zone of Proxima b is a narrow oasis of potential habitability, a place where extremes are moderated, where liquid water can persist, and where life, if it has arisen, could flourish. It is the twilight between fire and ice, the delicate margin between danger and opportunity, a world shaped not by seasons, but by eternal equilibrium. Here, in this band of perpetual dusk, the planet whispers the possibilities of life under a red star, a quiet reminder that even in extremes, balance can create conditions for existence. Proxima b may have storms that never end, blowing continuously from hot to cold side, loops of atmosphere in endless circulation. The heat of the sun-facing hemisphere drives air upward in constant updrafts, while the night side, frozen and dense, draws air downward, creating a perpetual cycle. Winds race along the terminator, the narrow band of twilight, transporting heat, moisture, and energy in a ceaseless flow. There are no seasons to interrupt this rhythm, no calm intervals of stasis, only an eternal, looping circulation powered by the relentless contrast of fire and ice. These atmospheric currents are immense and powerful. On the day side, air rises with such intensity that clouds form in towering columns, swirling and condensing as they are carried toward the terminator. Once at the boundary between light and darkness, winds spread horizontally, driving storms that stretch for thousands of miles. By the time they reach the night side, the air cools, descends, and flows back toward the warm hemisphere, completing a circuit that may never pause. The effect is a global system of energy transfer, a planetary heartbeat dictated by the immutable laws of physics and the unyielding energy of a red dwarf star. The storms themselves would be alien in character. Flare-driven bursts of energy from Proxima Centauri could amplify winds in sudden surges, whipping clouds into streaks of crimson and violet as auroral glows illuminate the skies. Rain, if it exists, might fall in irregular torrents along the terminator, while the nightside experiences drifting frost or ice precipitation. The atmosphere is a living, dynamic system, constantly reshaped by the interplay of light, heat, and magnetic interactions. Every gust, every swirl, is part of a planetary dance that loops endlessly across the surface. Winds also sculpt the terrain over millennia. Airborne particles, dust, and aerosols are carried across the planet, depositing minerals in some regions while eroding surfaces in others. Mountains and ridges are gradually smoothed or carved, valleys deepened, and coastlines reshaped. Even subsurface features may be affected indirectly, as winds influence temperature and pressure patterns, altering cycles of freeze and thaw in ice or liquid layers. The atmosphere, though invisible, becomes a primary architect of the planet's landscapes. For any life forms, these eternal winds impose constraints and offer opportunities. Organisms might evolve to anchor themselves, harness energy, or move with the currents, adapting to the persistent motion of the air. Patterns of moisture and temperature set by the circulation could define ecosystems, creating niches along the terminator or on the sunlit fringe, and forcing life to synchronize with the planet's continuous pulse rather than with any seasonal rhythm. Ultimately, Proxima B's winds are more than weather. They are the planet's lifeblood, a perpetual mechanism of energy transfer and environmental shaping. Circling endlessly from day to night, they bind the world together, connecting heat and cold, light and shadow, in a ceaseless dance. On this small, crimson world, the atmosphere never rests, and the storms that sweep it are both sculptors and storytellers, looping endlessly, writing the history of the planet in the language of wind. If Proxima b holds liquid water on its dark hemisphere, it would shimmer in eternal night, lit only by stars. These hidden oceans, insulated from the relentless glare and flares of the day side, would be realms of mystery and quiet beauty. Waves, if they exist, move gently under the influence of slow currents, tides pulled by the red star's gravity, and winds that curl along the terminator before fading into the frozen darkness. Reflections of distant Alpha Centauri A and B might scatter across the surface, adding faint glimmers to the unlit waters, while auroral light from the planet's magnetic interactions occasionally dances over the waves, painting fleeting patterns in crimson and violet. Beneath the surface, these oceans could harbor life independent of sunlight, sustained instead by geothermal heat and chemical energy. Hydrothermal vents at the ocean floor could spew warmth and minerals, creating islands of activity in a world otherwise dominated by darkness. In these hidden depths, ecosystems might flourish in isolation, developing unique biochemical pathways and evolutionary strategies. Without the need for photosynthesis, life would adapt to gradients of temperature, chemical concentration, and faint electromagnetic cues, making these oceans an entirely alien kind of biosphere. The circulation of water in these oceans is governed by contrasts rather than light. Heat from the interior warms pockets of liquid, driving currents that carry nutrients and energy, while cold from the nightside surface sinks, producing layers of density that flow in slow, eternal cycles. The oceans themselves are shaped by the planet's tides, which rise and fall with dramatic regularity due to Proxima's gravitational pull. This slow, persistent movement sculpts the ocean floor over eons, carving valleys, ridges, and basins, all in near-complete darkness. Ice may form above or around these oceans, shielding the water from the star's sporadic flares and cosmic radiation. Cracks and fissures in the ice allow exchange of gases or minerals, creating subtle interactions between ocean, ice, and atmosphere. The surface may appear frozen and lifeless, yet beneath lies motion, energy, and perhaps life, a world of activity invisible from orbit. Even the smallest disturbances, a chemical reaction, a venting plume, a drifting current, become significant in this silent oceanic realm. For any life forms, these perpetual night oceans offer both sanctuary and challenge. Predators, prey, and microorganisms would operate in complete darkness, evolving senses tuned to vibrations, chemical cues, or faint electromagnetic signals. Ecosystems could be entirely disconnected from the dayside, existing in a slow, insulated rhythm, shaped by the steady flow of heat, tides, and chemical gradients, rather than the transient bursts of light from the star. Ultimately, these oceans are a testament to resilience and adaptation. On Proxima b, water need not bask in sunlight to persist, and life, if it exists, need not follow Earth's patterns. Hidden, silent, and eternal, the dark hemisphere's oceans shimmer under starlight alone, a reminder that even in the absence of sun, worlds can hold complexity, movement, and the quiet possibility of life. Here, in the eternal night, the planet conceals beauty, motion, and perhaps the seeds of existence beneath its frozen, crimson-lit skies. A thick atmosphere could protect Proxima b from flares, allowing complex molecules to form and evolve. In a system dominated by a volatile red dwarf, radiation is relentless. Flares erupt without warning, sending streams of charged particles and intense ultraviolet light toward the planet. Without protection, these bursts could strip the atmosphere, scorch the surface, and break apart fragile molecules essential for life. But a dense, resilient atmosphere acts as a natural shield, absorbing, scattering, and diffusing harmful radiation before it reaches the ground. It becomes both guardian and incubator, creating a buffer where chemistry can proceed, where oceans can remain liquid, and where potential life might survive. The composition of this atmosphere is crucial. Layers of gases rich in nitrogen, carbon dioxide, or even exotic compounds could trap heat, moderate temperature extremes, and maintain pressure sufficient to sustain liquid water. Clouds might form thick veils, further diffusing sunlight and charged particles, casting the planet in muted hues of red and crimson. The atmosphere becomes a dynamic system, interacting with winds, tides, and magnetic fields to maintain equilibrium. In effect, it transforms a world that might otherwise be scorched and barren into one where chemical complexity and perhaps life can endure. Beyond simple shielding, a deep atmosphere shapes the planet's chemistry. Flare-driven particles interacting with atmospheric gases can spark reactions, producing molecules that would not exist under calm conditions. Nitrogen oxides, hydrogen compounds, and carbon-rich molecules can form in the upper layers, then settle or mix downwards, enriching oceans or surface regions with the building blocks of prebiotic chemistry. The atmosphere turns danger into opportunity. Flares that might destroy are transformed into energy that drives chemical evolution, fostering the potential for life's earliest steps. The thick atmosphere also smooths out the extremes of Proxima b's tidally locked environment. On the day side, it carries heat toward the night side, reducing temperature contrasts and helping maintain liquid water in regions along the terminator. Winds circulate continuously, transporting energy and material, shaping weather patterns, clouds, and even surface erosion. In doing so, the atmosphere becomes not just a shield, but a planetary engine, connecting light and shadow, heat and cold, in an endless cycle that stabilizes the environment. For potential life, this protection is fundamental. Complex molecules require stability to form, accumulate, and interact. The thick atmosphere shields them from destructive radiation, moderates temperatures, and allows cycles of evaporation, condensation, and precipitation to proceed. Even the tiniest organisms could exploit these conditions, using chemical gradients and energy from stellar interactions to survive, evolve, and adapt. In such a world, life would not simply endure, it would have the tools and stability to explore the chemical richness of its environment. Ultimately, Proxima B's thick atmosphere is more than a layer of gas. It is a planetary guardian, a mediator between star and surface. Radiation and chemistry, it converts danger into potential, chaos into order, and isolation into opportunity. Beneath its protective veil, the planet can host oceans, maintain heat, and allow molecules to dance, assemble, and evolve, a silent testament to the subtle power of atmospheric shielding in a universe defined by extremes. Some astronomers suspect a third world may lurk farther out, a planet yet unseen, waiting in the cold distance. Beyond the familiar orbits of Proxima b and c, the pull of gravity hints at a hidden companion, a world that has evaded detection by even the most sensitive instruments. It drifts silently in the dim outskirts of the system, bathed in faint red light from the star, distant enough that the warmth of Proxima Centauri barely reaches it. This hypothetical world, colder and darker than its inner siblings, may be frozen, mysterious, and profoundly different, a celestial secret tucked into the quiet depths of space. The possible existence of such a planet reminds us how little we truly know about even our closest stellar neighbours. Proxima's inner planets reveal the star's influence through tides, flares, and magnetic interactions. But a distant world would experience the star in muted whispers. Its atmosphere, if any exists, could be thin and tenuous, sculpted by eons of low-level radiation and occasional flares. Surface temperatures might hover near absolute zero, oceans frozen solid, and chemical processes slowed to geological patience. Yet, in these extreme conditions, surprises remain possible. Subsurface oceans warmed by internal heat, hidden geothermal activity, or chemical gradients could allow pockets of complexity or even life to exist, quietly defying the harshness of their environment. Gravitationally, this outer world interacts subtly with the inner planets. Its mass, orbit, and distance influence the resonances of Proxima b and c, shaping their paths and potentially stabilizing the system over billions of years. Though invisible to the eye and barely detectable to instruments, its presence may be felt in the rhythm of the system, a hidden conductor guiding the dance of its siblings. The farther a planet lies from its star, the slower its orbit, the more ancient its interactions, and the more it preserves the memory of cosmic history in its trajectory. The notion of an unseen planet also sparks the imagination. Could it harbor exotic chemistry, strange ices, or unusual minerals formed under conditions never experienced closer to the star? Could its darkness protect life from the harsh flares that batter Proxima b, allowing unique biological or chemical systems to evolve? In the quiet cold of the outer system, nature might experiment on scales impossible closer in, slow, patient, and hidden from view. Every orbit could carry it through regions of faint magnetic influence, tidal forces, and residual stellar wind, creating a rhythm known only to the cosmos itself. Ultimately, the possibility of a third, hidden planet turns Proxima Centauri from a simple system into a layered mystery. It reminds us that even the nearest stars hold secrets yet to be discovered, worlds waiting for patient observation, for exploration, or for the first glimpse of reflected light across the void. In the cold distance, a planet may drift silently, a testament to the richness and subtlety of the universe, proof that even in well-studied skies, surprises await those who look closely, and that the story of Proxima is far from complete. Proxima is the target of Breakthrough Starshot, the first attempt to send spacecraft to another star at a fraction of light speed. These tiny, laser-propelled probes are designed to carry cameras, sensors, and instruments across the vast gulf between the Sun and Proxima Centauri, a journey of more than 4 light-years. While the spacecraft themselves are small, the ambition behind them is enormous. To touch another star system, to glimpse worlds we can only imagine, and to bring back knowledge from a realm that has remained forever out of reach. In aiming at Proxima, humanity reaches for its first foothold beyond the solar system, a journey measured in decades, but whose implications span centuries and millennia. The mission is unprecedented in scale and daring. Lasers fired from Earth accelerate sails to incredible fractions of light speed, propelling them past the Sun's gravity and into interstellar space. Each probe is a fragile emissary, carrying the hopes of discovery across darkness that stretches light years. By the time they reach Proxima, even at these speeds, decades will have passed on Earth, and generations will have grown accustomed to waiting. Yet, for a star that burns quietly for trillions of years, a human lifetime is only a heartbeat, a fleeting moment in its cosmic vigil. Proxima itself will remain unchanged, silently waiting, as our probes approach and transmit the first direct whispers of another system. The journey itself is as much a philosophical exploration as it is technical. Humanity has never sent an object to another star. Even reaching Proxima is a demonstration of patience, ingenuity, and persistence. Instruments must endure radiation, micrometeoroids, and the unyielding cold of interstellar space. Communications are delayed by years, requiring probes to operate autonomously, navigating a void almost entirely empty, yet full of unseen hazards. Each success and failure is a lesson, a rehearsal for future generations of explorers who may one day follow these first emissaries with larger ships, crews, and ambitions. Beyond the engineering, the mission transforms how we think about distance, time, and connection. To reach Proxima is to confront the vastness of space directly, to measure human ambition against the immensity of the cosmos. Images and data sent back will reveal worlds in ways no telescope can, from the dim glow of oceans to the contours of mountains and ice, from the subtle hint of atmospheres to the magnetic and tidal rhythms of alien planets. It is a first step into a larger universe, a bridge between imagination and reality. Ultimately, Breakthrough Starshot is a story of courage and foresight. Proxima Centauri is no longer a distant red dot. It is a destination, a test of human ingenuity, and the first waypoint in our expansion into the galaxy. The path of future starships begins here, tiny sails cutting through darkness, carrying the earliest dreams of interstellar exploration. One day, perhaps, larger vessels will follow, transporting instruments, habitats, or even people. But for now, these probes are the vanguard, a fragile, luminous thread reaching across the void, connecting Earth to a distant, ancient star and heralding the age when humanity begins to step beyond the cradle of the sun. Even traveling at 20% light speed, a journey to Proxima would take decades, a cosmic road trip across the silent dark. For generations aboard hypothetical starships, the void would stretch endlessly in every direction, stars drifting slowly past as time unfolds differently within the vessel. Travelers would watch the familiar constellations of Earth shrink behind them, replaced by the unfamiliar glow of interstellar space, a tapestry of distant suns scattered across an ocean of emptiness. Every light year traversed is both distance and time, a measure of patience and endurance on a scale human civilization rarely contemplates. The journey is as much psychological as it is physical. Decades spent in relative isolation demand new ways of thinking about community, purpose, and exploration. Ships must be self-sufficient, capable of recycling air, water, and energy, while maintaining life support for extended periods. Supplies, habitats, and engines must all function flawlessly. But the real test is the endurance of the human spirit, the ability to gaze at unchanging stars and remain focused on a destination that is small, faint, and far away. The journey itself becomes a mirror, reflecting both the vastness of the cosmos and the persistence required to cross it. Time on such a voyage is measured differently. Days and nights might be artificially maintained, synchronized for human circadian rhythms, but the cosmic perspective dwarfs these cycles. Decades pass on Earth while the ship glides through interstellar darkness. Decades pass within the ship as travelers adjust, adapt, and contemplate the significance of reaching another star system. Proxima Centauri, when first detected as a faint red point, seems impossibly distant, yet the ship continues, propelled by light itself, narrowing the gap with every fraction of a second, every photon of energy converted into motion. Even at high speeds, the interstellar medium is not empty. Microscopic dust and radiation bombard the vessel, requiring shielding and constant vigilance. Instruments track distant stars and planets, mapping potential hazards and opportunities along the way. For those aboard, the journey is both exploration and survival, a balance between daring ambition and careful preparation. It is a test of human ingenuity, patience, and resilience on a scale that earthbound experiences cannot fully prepare one for. Arrival at Proxima would transform the concept of distance and time. The red dwarf would loom larger with each passing week, its planets emerging from the faint glow into detailed landscapes of color, terrain, and motion. What began as a point of light becomes a world of oceans, mountains, auroras, and hidden seas, a destination earned only through decades of patience, endurance, and unwavering vision. Ultimately, a voyage to Proxima is a meditation on the immensity of space and the limits of human perception. Even at a significant fraction of light speed, the journey spans decades, turning a star into a dream realized over a lifetime. It is a reminder that the universe is vast, that exploration demands time and persistence, and that the act of traveling across the cosmic dark is itself an achievement, a bridge between imagination and the distant, red glow of a neighboring sun. Of the thousands of exoplanets discovered, Proxima b remains the closest, the first world humanity might truly visit someday. Unlike distant, flickering points of light catalogued by telescopes, Proxima b is within the reach of human ingenuity, a tangible destination in the vast sea of stars. Its proximity transforms it from theory into possibility, from a red dot on a chart into a world that could one day be touched, studied, and understood. In the imagination of scientists, engineers, and dreamers alike, it represents the first step beyond the solar system, the gateway to the galaxy itself. The planet's orbit, tidally locked to its star, promises landscapes of extremes, endless day on one side, eternal night on the other, and a twilight band where light and dark meet in delicate balance. The Terminator Zone offers the greatest chance for habitability, where liquid water might persist and where any potential life could survive the flares and winds of the red dwarf. This narrow region becomes a focus not just of scientific interest, but of human aspiration, a target for probes, telescopes, and perhaps, one day, starships carrying humans themselves. The challenges of reaching and exploring such a world are immense, yet its proximity, just over 4 light-years away, makes them conceivable in a way that more distant exoplanets are not. Technologies like breakthrough starshot hint at the possibilities. Tiny probes could arrive within decades, transmitting the first images and measurements back to Earth. From these faint signals, humanity could map continents, oceans, auroras, and atmospheric conditions. Learning how this nearby planet lives under the gaze of its small red sun, each byte of data would transform our understanding, converting points of light into worlds with shape, color, and texture. Proxima b would become the first exoplanet that humanity can study directly, rather than indirectly, a laboratory for physics, chemistry, and potentially biology. Even the broader implications are profound. Reaching Proxima b is not just a technical achievement, it is a psychological and cultural milestone. It shifts the boundary of human ambition outward, reminding us that the stars are not forever unreachable. It allows us to contemplate life under a different sun, the survival of oceans and atmospheres under red light, and the rhythms of a planet without seasons. It challenges our concepts of distance, time, and exploration, showing that even a journey measured in decades can bring another world within our grasp. Proxima b's significance is amplified by its symbolic role. It is the first step in a future where humanity may one day traverse the galaxy, a waypoint on a route to countless other stars and planets. It represents hope, curiosity, and the enduring desire to explore the unknown. To reach it is to prove that we are capable of crossing the void, of extending our senses and tools into the cosmos, and of transforming distant points of light into destinations rich with meaning. Ultimately, Proxima b is more than an exoplanet. It is a mirror of our aspirations. It is the nearest world outside the solar system, a first chance to leave the cradle of the sun, and a reminder that the universe, though vast, can be touched, explored, and understood, one planet at a time. Because of Earth's tilt and Proxima's southern position, most of humanity will never see it, a hidden gem beneath our sky. For observers in the northern hemisphere, Proxima Centauri is perpetually below the horizon, invisible to the naked eye, concealed by the curvature of our planet. Only those closer to the southern latitudes can glimpse its faint, crimson glow, a subtle point of light among the brighter stars of the southern constellations. Even then, its presence is modest, overshadowed by the brilliance of more prominent celestial neighbors, yet it carries within it secrets and worlds of staggering significance. This star, small and unassuming, holds the key to the nearest known exoplanetary system. Its position in the sky has shaped how we discovered it, limiting early observations to those observatories fortunate enough to view the southern skies. Astronomers had to patiently track its motions, analyze tiny wobbles, and detect the faintest signatures of orbiting planets. Its subtle presence made its discoveries all the more remarkable, revealing a hidden world just over 4 light-years away, quietly circling a modest red dwarf, while humanity remained largely unaware above the northern horizon. Proxima's southern location also highlights the arbitrariness of perspective in astronomy. A star that is prominent to one hemisphere is invisible to another. A cosmic neighbor can remain a secret simply because of where we stand. For southern observers, Proxima Centauri rises above the horizon nightly, its red glow marking the closest gateway to interstellar space. To them, it is not merely a star. It is a destination, a guidepost, and a constant presence in the southern night sky. Its light, faint but steady, carries the promise of discovery, a reminder that the universe has treasures often hidden in plain sight. The star's hidden nature shapes both science and imagination. For most of humanity, knowledge of Proxima has come through telescopes and spacecraft, mediated by technology rather than naked eye observation. Its invisibility has not diminished its importance. Rather, it emphasizes how exploration often relies on ingenuity and persistence rather than simple visibility. Every orbit of Proxima b and c, every flare and magnetic ripple, occurs far beyond direct perception for billions. Yet we can study, measure, and model them, turning obscurity into understanding. In cultural terms, Proxima's hidden status invites wonder and curiosity. It becomes a star for those who seek, a prize for those willing to look beyond the obvious, a celestial reminder that some of the universe's closest marvels are also the most concealed. The idea that a star so near, hosting planets and potential life, remains invisible to most of humanity, adds a layer of mystery, a quiet challenge to our perception and attention. Ultimately, Proxima Centauri is a star both near and hidden, a crimson jewel moving slowly across the southern sky. It reminds us that proximity does not guarantee awareness, and that the universe often reserves its closest wonders for those who search carefully. Beneath our sky, out of reach for many, it waits silently, the nearest exoplanetary gateway, a hidden neighbor, and a quiet testament to the vast, often unseen richness of the cosmos. Proxima's flares challenge the limits of biology. If life survives here, it may survive anywhere in the galaxy. The star's sudden outbursts unleash torrents of radiation, X-rays, ultraviolet light, and charged particles that strike planets with immense energy. On Proxima b, these flares batter the atmosphere, spark chemical reactions, and alter the very molecules of life. For any organism, survival requires resilience beyond what Earth's life experiences daily. Yet, This extreme environment also creates opportunities for adaptation, forcing life to innovate, hide, and endure in ways that push the boundaries of biology itself. Life on Proxima b, if it exists, would need extraordinary defenses. Thick atmospheres, magnetic shields, or subsurface habitats could protect delicate chemistry from destructive radiation. Microbial life might thrive underground or under ice, insulated from the worst effects of flares. Photosynthetic organisms, if any, would need to tolerate bursts of intense radiation while making the most of the dim red light the star provides. Each flare is both hazard and catalyst, challenging organisms to endure, adapt, and potentially evolve rapidly in response to repeated assaults. The star's activity also shapes chemistry in ways that could favor the emergence of life. Radiation breaks molecular bonds and forms reactive compounds, sparking chemical pathways impossible under quieter conditions. Over millions of years, these processes could create a rich inventory of complex molecules, some of which might serve as precursors to life. Proxima's flares act as both sculptor and teacher, continuously shaping the environment and testing the limits of chemical and biological resilience. A life form that endures here demonstrates not just survival, but adaptability to extremes that dwarf anything on Earth. For astrobiologists, Proxima is a natural laboratory. It provides a glimpse into the conditions under which life could arise in hostile environments across the galaxy. If organisms exist on Proxima b, they may be capable of withstanding radiation, temperature extremes, and chemical volatility far beyond Earth's norm. This resilience would inform the search for life elsewhere, offering models for what to look for on planets around other red dwarfs, or in extreme zones near young, active stars. Life in the Proxima system would redefine what we consider habitable, showing that even under harsh bombardment, the persistence of biology is possible. The stakes are cosmic. Proxima's flares strip, burn, and disrupt. Yet a planet that maintains chemistry, oceans, or life under this assault becomes a proof of concept that life can survive almost anywhere, provided the right conditions of protection, adaptability, and chemical richness. It reframes our understanding of the galaxy as a place not of barren stars alone, but of worlds where life could find niches in the most unlikely corners. Ultimately, Proxima's flares are both test and opportunity. They define the harshest possible limits, and any life that endures here would embody resilience on a universal scale. In confronting these extremes, Proxima teaches that biology is not fragile, but remarkably persistent, capable of thriving in the silent, fiery challenges of the cosmos. It is a reminder that where the star's light touches, and even where its storms rage, life may yet find a way to endure. In its youth, Proxima flared even more violently than today. Any life that arose would need resilience beyond Earth's earliest organisms. Billions of years ago, this tiny red star was volatile and unpredictable, its bursts of radiation far more frequent and energetic than those we observe now. Planetary surfaces would have been constantly bombarded, atmospheres intermittently stripped, and chemical bonds repeatedly broken. Any nascent life would have been tested at the limits of survival, forced to find refuge underground, beneath ice, or in chemically protected niches. The earliest chapters of Proxima b's history were written under a storm of radiation, a cosmic crucible shaping the potential for life to endure. This extreme environment may have acted as a filter, favoring only the most robust and adaptable organisms. Simple microbes capable of repairing DNA damage rapidly, forming protective biofilms, or harnessing chemical energy independent of sunlight could have survived. The violent flares, paradoxically, might have driven the formation of complex molecules, sparking chemical reactions that would be impossible under calmer conditions. In this sense, the star's youthful fury was both destructive and generative, a force that both challenged and enabled the earliest steps of biology. The legacy of these early flares is still written across the planet. Atmospheric composition, chemical gradients in oceans, and the mineralogy of the surface may all bear the imprint of billions of years of stellar activity. Layers of rock may hold clues to repeated radiation exposure, and subsurface reservoirs could preserve evidence of life's earliest adaptations. For any life forms that survived, their strategies for enduring extremes would become encoded in their evolution, shaping biology capable of withstanding far harsher conditions than most Earth life ever faces. This turbulent past also informs our understanding of habitability around red dwarfs. Proxima b demonstrates that a planet orbiting a highly active star can still maintain the potential for life, provided certain protective mechanisms exist. Thick atmospheres, strong magnetic fields, and subsurface refuges could all counteract the worst effects of flares, allowing chemistry and biology to proceed despite the star's violent youth. In a galaxy filled with red dwarfs, the most common stars, these lessons suggest that life may persist in places previously thought uninhabitable, resilient against forces far beyond Earth norms. For humanity, the shadow of Proxima's early years is a reminder of endurance on cosmic timescales. Life on this planet, if it exists, is the product of billions of years of struggle against a volatile sun. Its survival would testify not to luck alone, but to the extraordinary capacity of organisms to adapt, repair, and thrive in conditions far removed from the relative calm of Earth's early environment. It is a testament to resilience, a model for how biology can endure when the universe seems most hostile. Ultimately, Proxima's early fury casts a long shadow, one that may define the character of life within its system. Any organism that persisted through its storms carries the history of survival, adaptation, and ingenuity on a planetary scale. The star's violent youth reminds us that the universe is not always gentle, but that where extremes exist, life's persistence is both remarkable and possible. A lesson written in crimson light across billions of years. Proxima rotates slowly, its pace calm and lethargic, like a star dreaming through eternity. Unlike massive stars that spin rapidly and exhaust their fuel in millions of years, Proxima's rotation is measured, deliberate, and serene. Each turn of the star is a slow, patient beat in the rhythm of the galaxy, a reminder that some celestial bodies move not in haste, but in the languid cadence of time stretched across billions of years. Its quiet rotation shapes the behavior of its flares, magnetic fields, and atmosphere, creating a stability that contrasts with the chaos of its early life. This slow rotation has profound implications for the planets that orbit it. Magnetic fields generated by the star's core are influenced by its spin, affecting the way charged particles move through space. A more stable magnetic environment means Proxima b and any neighboring planets can experience calmer periods between stellar storms, providing windows of relative safety where atmospheres and chemical processes can persist. The slow spin acts as a metronome, pacing the interaction of radiation, winds, and orbital dynamics over epochs, and offering a subtle predictability in an otherwise volatile system. The lethargic rotation also affects the star's energy output. Proxima's flares, though still powerful, are less frequent than in its youth, and the dim red light it emits remains consistent over vast timescales. This constancy allows planets in the habitable zone to experience predictable thermal conditions, stabilizing climates along the terminator line of Proxima b. In a universe filled with stars that flare unpredictably or burn out in brilliant lifetimes, Proxima's patient rhythm offers an unusual constancy, a cosmic heartbeat that endures while civilizations, if they arise, live and evolve in its quiet shadow. For astronomers, the star's slow spin is a clock against which the history of its system can be measured. Flares, rotational modulation, and magnetic cycles can be observed over years, decades, and centuries, revealing patterns that illuminate the long-term evolution of planets and potential biospheres. Proxima's pace is a laboratory for studying stellar physics, showing how a star's rotation influences habitability, radiation exposure, and the long-term stability of orbiting worlds. It is a slow-moving, yet powerful instructor, teaching us the lessons of time, patience, and cosmic endurance. In cultural and philosophical terms, Proxima's calm rotation invites reflection. The star's patient, lethargic motion contrasts with humanity's frenetic pace, reminding us that the universe often operates on timescales far beyond our comprehension. While our lives are measured in years, decades, and centuries, Proxima ticks in billions. A star indifferent to urgency yet deeply consequential for its planetary companions. Its slow rhythm allows life, chemistry, and exploration to unfold with a continuity that Earth alone cannot guarantee. Ultimately, Proxima's rotation is a cosmic clock, ticking softly across the galaxy. Its pace is a measure of endurance, a symbol of stability, and a reminder that in the universe, time is not always hurried. For planets like Proxima b, this patient spin creates a stable stage on which life could emerge and persist, where chemistry can play out over eons, and where the quiet heartbeat of a tiny red star defines the tempo of worlds in its orbit. In its slow, dreamlike rotation, Proxima offers both a sanctuary and a lesson that even in a turbulent galaxy, some stars move with patience, shaping possibilities across the ages. Studying Proxima's planets shows us what Earth might face under different skies, how worlds evolve, adapt, and survive around small, long-lived suns. Proxima Centauri, dim and ancient, offers a glimpse into conditions unlike those on our familiar blue planet. Its planets orbit close, exposed to flares, winds, and magnetic storms far stronger than anything Earth endures. Yet these worlds endure, maintaining atmospheres, oceans, and potentially chemistry conducive to life. By observing them, we can understand the resilience of planetary systems, the interplay of stellar activity with climate, and the ways in which life, if it exists, might persist under extreme and unrelenting conditions. The longevity of Proxima as a red dwarf provides a unique perspective. While the Sun will burn for roughly 10 billion years, Proxima's lifetime stretches trillions, its energy output steady for epochs beyond human comprehension. Its planets, therefore, have had, and will continue to have, immense stretches of time to evolve and adapt. Studying these worlds offers a window into long-term planetary stability and change, showing how ecosystems or chemical processes might persist over timescales far exceeding Earth's own history. They are laboratories for patience, endurance, and survival in a universe governed by extremes. Proxima also serves as a natural test case for the impact of stellar flares, winds, and radiation on planetary atmospheres. Earth's magnetic field and thick atmosphere shield us from solar storms, but Proxima b experiences flares orders of magnitude stronger than the Sun's most powerful outbursts. Observing how its atmosphere, and potentially life, copes with such assaults provides insight into the limits of habitability. The lessons extend beyond this one system, informing our search for life around the millions of red dwarfs scattered throughout the galaxy. It is a mirror not only of possibilities but of adaptability, how worlds respond, survive, and perhaps thrive despite adversity. The planet's tidally locked orbit, its terminator zone of perpetual twilight, and the hidden dark oceans further enrich the picture. They show how energy gradients, wind patterns, and orbital mechanics create environments where extremes are moderated, where life could persist despite one hemisphere baked under constant light and the other frozen in eternal night. Each detail helps us imagine alternative evolutionary paths, alternate geographies, and different strategies for survival, a form of cosmic anthropology applied to planetary science. Ultimately, Proxima and its planets are both a laboratory and a mirror. They show us what is possible when worlds endure long beyond human scales, how stability and volatility coexist, and how life, if it arises, must adapt to conditions far stranger than those on Earth. By studying them, we gain perspective on our own planet's future, imagining scenarios under different stellar influences, and appreciating the resilience required for long-term survival. In this way, Proxima is not just a neighboring star, it is a guide. Its planets reflect the potential paths Earth could take under different skies, offering lessons about endurance, adaptation, and survival across cosmic time. Observing Proxima's worlds allows us to see ourselves from the perspective of the universe, a fragile, evolving planet in a galaxy where patience, resilience, and adaptability are the keys to enduring across the ages. As our journey draws to a close, let your mind drift gently back from the red glow of Proxima Centauri. We've wandered across its faint light, traced the contours of its hidden planets, and listened to the quiet pulse of the nearest star beyond our sun. We've seen how something so small can shine for trillions of years, how a distant world like Proxima b may cradle the ingredients for life, and how even the smallest ember in the sky holds mysteries deeper than oceans. Proxima reminds us that the universe doesn't measure significance in size, that even the dimmest star can shape worlds, sculpt atmospheres, and spark the imaginations of civilizations not yet born. It teaches us patience, the kind only trillion-year stars understand. It teaches us humility, reminding us that our sun, so bright and dominant in our sky, is just one flame among countless others drifting through the dark. And perhaps most beautifully, Proxima shows us connection. A star only 4 light-years away means that the galaxy is not an empty wasteland, but a community, a cosmic neighborhood waiting quietly just beyond the reach of our rockets, whispering that we are surrounded by possibilities, not isolation. As you settle into rest, let these thoughts cradle you like starlight across a calm sea. You live in a universe filled with wonders. You are part of a story unfolding across billions of years. And even in the vastness, you are not small. You are woven into the fabric of something extraordinary. Allow your breath to slow. Let your mind soften. Feel the peace of knowing that the stars are still burning, still guiding, still keeping watch over the silent night. Sleep well, traveler. And until our next journey, good night.